C programming language is considered as the mother of all programming languages present in the software industry. Anywhere you go, C programming language is the most basic and very important aspect which the recruiters are looking for. Hi, this is John from Programming Knowledge and welcome to this video tutorial series where you will learn how to go about programming in C language. In this tutorial, we will discuss mostly the important parts of C programming language. So these are the topics that are included in our C programming language tutorial series. So firstly, we're going to discuss the history of C and then to be followed by the installation of C. So I'm going to guide you through all the steps needed to start about programming in C programming language. To be followed by data types and variables. Of course, we're going to discuss the importance of data types and variables in C. And to be followed by C tokens. To be followed by preprocessor directives. And of course, we're going to learn how to write our first program in C programming language. And of course, to be followed by control structures. So as we all know, if you are coming from other programming language, you already have knowledge on control structures. So we're going to discuss that right here. And then of course, loops. We're going to discuss loops. And then pointers. And to be followed by functions. And then we're going to learn about escape sequence in C. And after that one will be the data structures. And of course, we're going to discuss strings, followed by structures and union, to be followed by memory allocation, and lastly is the sorting algorithms. So we're going to discuss that also in this particular tutorial series. So now let's talk about the history of C language. So history of C language is interesting to know. Here, we are going to discuss a brief history of the C language. C programming language was developed in 1972 by Dennis Ritchie at Bell Laboratories of AT&T or American Telephone and Telegraph, located in the USA. Dennis Ritchie is known as the founder of the C language. It was developed to overcome the problems of previous languages such as B, BCPL, and other languages. Initially, C language was developed to be used in Unix operating system. It inherits many features of previous languages such as B and BCPL. C was originally first implemented on the DEC PDP-11 computer. So PDP-11 is a series of 16-bit mini-computers sold by Digital Equipment Corporation from 1970 into the 1990s. C programming language is known for its flexibility and versatility, allowing maximum control with minimal commands. So now let's talk about the features of C language. C programming language is the widely used language and it provides many features that we're going to discuss in this particular video. Number one, it is simple. C is a simple language in a sense that it provides a structured approach to break the problems into parts. Number two, machine independent or portable. So unlike assembly language, C programs can be executed on different machines with some machine specific changes. Therefore, C is a machine independent language. 3. Mid-level programming language. Although C is intended to do a low-level programming, it is used to develop system applications such as kernel, driver, and others. It also supports the features of high programming language. That is why it is known as mid-level language. Number 4. Structured programming language. C is a structured programming language in a sense that we can break the program into parts using functions. So it is easy to understand and modify. Functions also provide code reusability. Number 5. Rich library. C language provides a lot of built-in functions that make the development faster. Number 6. Memory management. It supports the feature of dynamic memory allocation. In C language, we can freely allocate the memory at any time by calling the free function. Number 7. Speed. The compilation time and execution time of C language is fast since there are lesser built-in functions and hence the lesser overhead. Number 8. Pointer. C provides the feature of pointers. We can directly interact with the memory by using the pointers. We can use pointers for memory, structures, functions, array, and others. Number 9, recursion. In C, we can call the function within the function. It provides code reusability for every function. Recursion enables us to use the approach of backtracking. Number 10, extensible. C language is extensible because it can easily adapt new features. Now that we're done talking about the features and history of C programming language, we can now go to the installation of C in Windows operating system. Now, there are multiple ways we can install C programming language in our computer system. So the most basic way is to install Turbo C in our computer system. Also, if you're familiar with the Eclipse IDE, you can directly download GCC compiler and include C nature to our Eclipse IDE and continue working on executing C programs. As I've said guys, there are multiple ways of installing C program into our computer system, and one way of doing it is to install Turbo C++, or you can use the Eclipse IDE and then include the GCC compiler, and also you can do it online. There are many platforms that can help you develop C program online. And then one way of doing it is also installing code blocks. So if you go to your browser and try to search for code blocks, and then this is the first link that you will get, and it will redirect you to codeblocks.org. And codeblocks is an IDE that will help us to write programs, especially for C, C++, and Fortran IDE. The good thing about codeblocks is it is a cross-platform and open source, meaning we can use it freely to develop our C programs. So the first thing that we're going to need, guys, is to download this, of course, in order for us to install and start writing our C programs. So there are two options here. We can download it from this link, and of course, we can also download it from this particular link here. So let's just try this one, the upper one, and then there are options to download the binary release. We can download the source code, and we can also retrieve source code from SVN. Okay, the first thing that we're gonna need now is to download the binary release. Okay, you click on that, and here we can see that we can install it on Windows XP, Vista, Windows 7, Windows 8, and Windows 10. And we can install it also in Linux operating system, be it 32 or 64-bit. And also we can use it on Mac OS X. And because we're using Windows operating system for now, so let's just click on that. And then here we can see all the options or all the links that we can download the code blocks. We can download only the setup. We can also download the non-admin, no setup, and then we can also code blocks with this MingW setup. So if you want, you can download this particular one, code blocks, and then the current version is 17.12 mingw-setup.exe, and then we can download it from SourceForge or FossHub. So try that, and then let's just wait for the download to complete in order for us to install this particular IDE. And then after installation, of course, we can write our first program in C programming language. So currently it is 86.2 MB, and then we're just going to wait for a few seconds for the download to complete. And I think it won't take that much time, and we're halfway there. There you go. So we can just install this particular IDE. So click on this. And yes. Next. I agree. And then we don't want to touch anything here. If you are an advanced user, you can try to modify the installation, but for now, since we're beginners, let's try to click on next and then install. This is the destination folder, and then install. So there you go, installation is complete. So do you want to run code blocks now? Of course, yes. So GNU's GCC compiler has been detected, so that's okay. And file associations, we are being asked here if we want to associate C and C++ files for this particular IDE. So yes, associate code blocks with C or C++ files, and then okay. So there you have it. We now have the installation of code blocks. And so for this particular video, guys, we're going to talk about our first program or C program. So basically, we also discuss how to install code blocks. And here you can see I'm using code blocks to create our C program. Okay. So here we have the basic program or basic C program. Okay. And before that, I'm going to show you how to create project here in code blocks IDE. So the first thing that we're going to need is to create a project. So instead of using this particular file test.c, we're going to close that and then create our new project. So let's go to file and then new, and then there's an option here for creating our project. So basically all we have to do is select here a type of application that we want. So for example, we're going to just create a basic application or basic C program. So let's try to find that here in this options. So we're going to select the first one, which is the console application, because we're going to start with a very basic application. So go and then next. So it should be C. Project title will be Programming Knowledge Tutorials, and then let's just select the actual directory to use. So let's just say the documents, and then we're going to create a new file here or a new directory, C projects, and then okay, and then next. And then we don't want to mess around here, so just basically finish the wizard for now. So finish. So we have here our project, Programming Knowledge Tutorials, and we have here the sources, and by default it created this particular file, main.c. So as you can see, we have here some parts or pre-populated code for us. So we have the very basic structure of a basic C application. So if you try to run this, let's just try to run this first before we go any further with our tutorial. So let's just run, and then it will ask to build our project. So of course, yes. And then there you go. You can see here the hello world text. So basically what this program is doing is just printing hello world string or text into our monitor or this particular console. So press any key to continue, or you can just close this particular command prompt. Okay, so if you want to make the text or the code bigger, you can just control scroll by using your keyboard and your mouse, of course. So I'm just going to make it bigger so that you will be able to see what I am doing here with our project. So first, I'm going to discuss first the parts of this particular program or basic program of C. So basically we have the lines 1 and 2. So basically it is the like import statement of this particular program. So it is basically saying that we need these files and we need to include this in our new program or new file, main.c. So we have here the include and then stdio.h and include stdlib.h. So basically these are header files. Okay, so these are files and we need functions from those files. So for example, we have here the functions printf here. So this particular function is inside or can be found in stdio.h file. Okay, and here we also have the int main, as you can see here. So the int main is the main function. This is the entry point of every program in C language. So in normal terms, it is basically the entrance. And every time we run our project, it will try to find the main function of our project. So it should have like one main function for in order for us to run our program. So int main, so basically it says that the return type is an int, and then everything inside this curly braces, open and close curly braces, is part of this particular function main. And we have two lines here, so printf and then semicolon and then return 0 and then semicolon. So these are the lines of our int main function. So in order to terminate a line, you need to add semicolon at the end of that particular line. So just like this here, and of course just like right after this return 0. So now I'm going to explain what this function does. So the printf is a function used to print data on the console. So basically we're just telling our program to output hello world, and then it should return 0. So return 0 statement, it means that the return execution status of this particular program, and the 0 value is used for successful execution and 1 for unsuccessful execution. So let's try to run this again. Anyway, you can just run or build and run your project, or you can just run it by pressing this particular run button. Okay, so as you can see here, we have this particular string or output hello world, and if you try to add a new line for our program, printf, and then everything that we want to display, it should be inside the double quotes. Okay, C programming is awesome. Okay, and then of course we need to end this particular line by adding the semicolon at the end, and then save. You can just build and run. So as you can see here, hello world and then C programming is awesome. So notice that we have added this particular character here, \n. So we're just telling the program to add another line or to go to a new line after printing the hello world or the hello world string, this one. And let's try this also for this particular second line, and build and run. Okay, so as you can see, after printing the C programming is awesome, it added a new line here, which you can see as a space between C programming awesome text and process returned 0. So there are other texts or other keywords also for this. Instead of using slash or \n, you can use \t for tab or for tabbing. So let's try that. save, and then build and run. So as you can see, there is a significant space between programming word and the word is. So this will come in handy if you're trying to work with like tabular data. So \t will be like very useful for you because it will format the columns for you, and as I've said, it will be a great help. So the next thing that we want to talk about is the order of execution in every C program. So basically, if we have like 4 lines here to print something in our screen like this, so as I've said, in C program, it is executing in order line by line. So this will be the first one, or the first line to be executed, and then the second line to be executed, the third line to be executed, and the fourth line to be executed. So for example, we'll try to make this 2, and then 3, or I mean 3, and then 4. Let's try to build and run this. So we have the output as hello world, hello 2, hello number 3, and hello number 4. So basically, all the statements are executed in order line by line. So for example, we have, or we want to draw something in the screen. So like we want to draw a triangle. So here, and then another one here, and then another one, just to show you the sequence of execution of this particular C program. So right here, another slash, and then here, and maybe here, and another one, another line, or vertical line, and also here. And we need to add the new line or line break for this print statements, and we can make this or add like the underscore. And let's try to build and run this, and you can see we have the triangle displayed in our screen, and that means that the lines has been printed or has been executed in order line per line. So if we try to make changes, and instead of placing it here, let's place it before printing the first line. So the output will be like this, funky looking shape. That's because we execute the first statement to have like the forward slash, the underscore, and then the vertical, and that's why we have an output like this. So just bear in mind that in every program, it is executing line per line. Okay? So now let's try to discuss placeholders. Okay? Placeholders for different data types. So in programming, there are types or data types that we want to work with. So for example, string, we have characters, we have integer, we have float, and other data types. So for example, you want to display string, you just have to like say hello world, and this is a string. Let's just remove this. Okay, save and run and build. So we now have like the output of our program hello world. This is a string. But if you want to try it, or if you want to print a number, so for example 32. So let's try this. Run and build, and as you can see, we have returned -1073481, or 18 and 19. So basically what this means is that there's something wrong with our program, because as I've said before, 0 should be the standard or the return if the program runs smoothly, or there's no problem while running our program. So basically here we have negative, so it means we have problems, right? And we can see here that note expected constant char, but argument is of type int, as you can see here. So basically we cannot directly display number by using this, so we can use placeholder for that. So this will be for our placeholder. So instead of using directly 32 here, we can say % and then d. So d is for integer. So if you want to display integer, you might want to use the %d placeholder, and then inside this printf statement you need to add the comma, and then of course the value that you want to be printed. So %d and then comma and then the actual value that you want to be printed. So let's try that. Build and print, or build and run, and as you can see here, process returns 0, and then we have here the value 32. So let's try this one more time, \n, build and run, and here we can see clearly what is happening here. So hello world, this is a string and the value 32. So that's the purpose of %d, is a placeholder for an integer value. Another one we have for large integer. So for example, there are like a very large number or very large integer. The keyword for that, or the placeholder for that, is LD, which stands for large integer. Okay, so for example, we have like very big integer right here. Okay, so that's the placeholder %LD. And then of course we also have for decimal values or float values. So for example, you want to say 32.5 or 32.5. This is for, again, decimal or float value. Okay, let's just say float value here. So %f, %d for integer, %ld for large integer, %f for float number, and another one for large float. Okay, so this will be for large float, and then another one for, so for example, you want to display a character, and you want to display like letter A. So the placeholder for that is %c, and then the actual value that should be typed in inside the single quote characters. So this will be for a char or character. And then another one is for the string. So for example, you want to display hello world. This is a string, and then you want to display that. You can also use %s for the placeholder for that. So you can say hello from printf. Okay, so this will be for our string. So basically, string is just a series of characters, meaning string is just composed of several characters. So for example, this one, HELLO and FRO from, and so on. You get the idea. But basically, all these placeholders can be used to display different values or different types of values. The integer, large integer, float, large float, character, and string. So let's try to display this and maybe add the \n here and here, also here, 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 and here. So build and run. There you go. You can see here the output of our program, and we did not specify directly the values of this figures. So instead, we're using printf and then the placeholder. So for example, %d for integer, %d for large integer, and so on. And in this tutorial, guys, I want to talk to you guys about variables in C. Now, when we're using C programming language, a lot of times we're going to be dealing with data. So there's going to be different data values or different information that we're going to want to keep track and use inside of our programs. And sometimes it can be difficult to maintain and keep track of all that data, and that's where variables come in. So basically, variable is essentially a container where we can store different pieces of information. So different data values, we could sort of things like numbers or text or characters. And these variables make it a lot easier for us to keep track and manage all the data in our C program. So I'm going to show you guys basically how variables work, or how variables can be useful and how we can use them in our C programs. But down here I have a very basic program. So I'm basically just printing out a little story. So it says there once was a man named Mike. He was 50 years old. He really liked the name Mike but did not like being 50. So this is a simple program. We're just printing out a bunch of different lines of text, and then when I run this program, you'll see we print out the actual story. So over here we have the actual story, and this is great. Okay, but let's say that I'm reading through my story and I'm reading through my program, and I'm thinking to myself, I think I want to change the character's name. So instead of calling the character Mike, why don't we call him like John in order to make that change? So I'm gonna have to look through my entire program and find every place where we mention the character's name. So right here is one, so change it to John. And remember, keep looking here, and there's another one. So we'll change this to John, right? So I had to manually go through and change every instance of the character's name to John. So let's say that's okay. That sounds pretty good. But maybe I'm thinking I want to make the character a little bit younger. So instead of like 50 years old, so let's change it to maybe 30 years old instead of 50 years old. Okay. We're going to change here. He was 30 years old, and also in here, the last line of our story. So that's 30 instead of 50. If I was to run this program, then all that information will be updated and we'll now have new story. Okay, so here's the problem though. I'm dealing with a very short story. So I mean, this is 4 lines. We only mention the character's age and name only twice. But imagine if I was writing out a huge C program that had hundreds of lines in the story. So story had hundreds of lines, and maybe we mentioned the character's name hundreds of times. They mentioned their age hundreds of times, and if we wanted to change the character's age or name, I would have to go through and manually change it every single location, and that would take forever, and it would be a huge drag for us to change all the instances of the name of our character and also for our for the age of our character. So basically, that's not a good way for us to manage and maintain the data for our programs. Okay, basically we have 2 pieces of data that we're working with, and consistently in this program, the character's age and the character's name. What I want to show you guys now is how we can use variables to better keep track, manage these pieces of information. So remember, a variable is basically just a container where we can store some data. So I want to create two variables which will store the character's name and the character's age. And I'll show you guys how this can make our program a lot easier to manage. Up here, before the print statement, I'm just going to make a new line, and I'm gonna come over here and I want to create a variable. Now, whenever we create a variable in C, we have to give C a couple pieces of information. The first thing we have to tell C is that what type of information we want this variable to store. Now, I'm going to get into the different data types that we can represent and see more in the next tutorial. But for now, just know that there's a bunch of different types of data that we can store, and we can store things like numbers, characters, we can store text, we can store decimal numbers, all sorts of stuff like that. In our case, I'm going to store the character's name and the character's age. Basically just a collection of characters. So in order to create this variable, the first thing that I have to tell C that I want to create a variable that's going to store some characters, and to do that I'm just going to type out char here just like that, and basically telling C we're going to store characters inside of this variable. So after we type out char, I wanted to type the name of the variable that I want to create. Remember that a variable is a container, and it's a good idea for us to give these containers descriptive names, and those names will basically let us know what that variable is storing inside of it. So I'm going to call this character name. Now what I want to do is basically I want to store multiple characters. So over here we're telling C that I want to store a character, but in C we can also store, instead of just storing like one single character, we can store a bunch of characters, and that would be kind of like, a name. So there's like 4 characters in here. So in order for us to store a bunch of characters inside of this particular variable, after we type the character variable name, we're gonna have to make an open and close square brackets, and that's gonna tell C that we want to store a bunch of characters inside of this particular variable. So char character name, open and close square brackets. I'm gonna set this equal to something. So I am essentially assigning a value to this particular variable, and I'm just gonna make an open close quotation marks. So equals and then quotation marks, and inside of here we're gonna type out the value that we want to store. So in my case, I'm just gonna store the character's name, which is John, and then as always in C, we're gonna have to end this off with a semicolon. So alright, basically what I did here was I created a variable, and I told C that I want to store in the variable, I wanted to store a character, and I give this variable a name, character name, and then I use this open and close square brackets to tell C that I wanted to store a bunch of characters, not just one. Now what we can do is we can make another variable to store the character's age. So in this case, we're gonna do something similar, but we're gonna want to store a number. And there's a bunch of different ways that we can store numbers in C, but for our purposes, we're storing age. So we're gonna use something called an integer, and an integer is basically just a whole number. So I'm just gonna type out int here, int, and that basically stands for integer. And now we're gonna give this name. So I'm gonna call this character age, and I'm gonna set this equal to a number. So in our story, the age is 35. So I'm just gonna type out 35 there, and now we can again end this off with a semicolon. So I have here 2 variables, this one storing the character name, and this one is for our age. Now, the question becomes how we can use this inside our program. Well, basically, what we can do is we can print them out alongside with this text, and we can actually use this printf function in order to do that. So I'm gonna show you guys how to do this, and then we're gonna talk about it. So basically, I'm gonna go over here, and as you can see, we have here the character name, which is John. Okay, so we can replace this with %s. So %s is basically a placeholder. So after this, we're going to add comma here, and then we're gonna add the character name variable. So basically, we're telling C that we're going to print this particular text, and %s is just a placeholder that will automatically be replaced by the value of our variable character name. So we have the first instance of the character name, and then right here we also need to replace this with %s, and then add comma, and then character name, because we want to replace that with our value of our variable character name, which is John. And of course, like here, we also need to replace this with the actual value of our character age. So what we can do here is just we can add %d. So %d is also a placeholder for printing the integer. So this is like integer character age equals 35, and then %d, and then we're gonna add comma here. So, and then character age, the same thing here, character age, and then we're going to replace this with %d, a placeholder for integer. So if we're trying to run our program, so let's do that, build and run, and we should have the so we have a process return. So I think we have something, or we have an error with our program. So let's try to debug this. So warning, format S expects per argument type of character, but argument 2 has type int. That's basically because we didn't add the square brackets there. So build and run. So there you go. We have now the output. There once was a man named John. He was 35 years old. He really liked the name John, but did not like being 35. And of course, every time if we want to change something with this story, so for example, instead of John, we will say Michael, and we can change also the age, like 40, and then exit that, and then build and run. So as you can see here, we now have the updated story. So Michael, and then 40 years old. So the good thing about variable is that we can reuse this into our entire program. So we have every time we have changes here, all the variables or all the value should be reflected in our the rest on our program. So in our case, we have updated all the values for our story. And in this video, guys, we're gonna talk about variables, and of course we will have a deeper discussion on how to declare, initialize, and assign values to our variables. So basically, guys, like most programming languages, C uses and processes variables, and in C, variables are just like human readable names for the computer's memory addresses used by a running program. So basically, guys, the advantage of using variable is it is making our life easier to store, read, and change the data within the computer's memory by allowing the or by allowing us to associate easy to remember labels for that particular memory addresses. So at first, it is easier to imagine that variables are just placeholders for values, much like in mathematics. So you can think of a variable as being equivalent to its assigned value. So for example, if you have a variable that is I, and then initialize or set equal to, so for example, 4, so by that you can say that I plus 1 will be equal to 5. So there you go. So now let's talk about how to declare a certain variable in our C program. So basically all we have to do, guys, so for example, if we try to declare an int, or say for example int and then some number, okay, and then you have to end it with a semicolon that signifies that it is the end of this particular line. So this statement tells the compiler to create a variable called some number and associate it with a memory location on the computer. So we're also telling the compiler that the type of data that will be stored at that address, and in this case it is the int. We have to remember also that in C we must specify the type of data that a variable will store, because it will tell the computer like how much the total memory to set aside for that particular variable or set of data, something like that. Now you can also declare multi-variables in one statement. Just say for example int n1, and then you have like n2 and then n3, and then end it with a semicolon to signify that it is the end of this particular line. So that's basically how to declare a variable. So you can do it like this, and if you have like multiple variables to declare, you can just do it like this for as long as it is the same type. Okay, so int n1 and then n2 and n3. So we're just telling the compiler to declare this particular variable, and all of this variable the type is int. Okay, and of course you can assign a value to that particular variable later on using a statement like, so for example, some number equals to 3. Okay, so basically this is the declaration of our variable some number, but this is the assigning of value. So we're just basically assigning value 3 to our variable some underscore number. So the assignment of a value to a variable is called initialization. So we're just basically initializing the value of this variable some number equal to 3 or something like that. And of course you can just maybe you can declare, initialize, and assign value at the or in one line or something in the same time. So int age equals to 4, something like that. So you can declare the value or the variable and then assign value to that particular variable. So okay, and of course you can assign variables to the value of another variable. So it means, so for example n1, you can assign the value of age into this by just using the variable age, something like that. Or you have to modify it with like add 10. Okay, so age and then plus 10 or something like that. And if you want to display this, all you have to do is use the function printf, and then you can say the age is %d, and as you can remember, this is the placeholder for int. So %d, and then you have to specify the variable. So for example n1. So let's try this. add semicolon to this. So compile and run. So the age is 14. So that's because the N1 now holds the value of age plus the value 10. So it makes it 14. Okay. And of course, you can assign multiple variables to the same value with one assignment. So for example, N1, N2, and N3, you can assign it like this. So I'm just showing you guys how to assign values to this particular variable. So for example, N1 equals N2 equals N3, and this should equal to 8. Okay, so let's try this, and as you can see, the value is 8. Okay, but if you try to display also N2 and N3, it will get also the value 8. So you can assign multiple variables to the same value with one statement. So now I'm going to talk about naming the variables, because there in naming, or I mean in C, we have to remember that there are naming rules that we have to follow. So one of the rules that we have to remember is that the variable name must not start with a digit. So basically, you cannot say int and then one age. You cannot do that, because as a general rule, you cannot start your variable name with a digit. Okay, and of course the second one is spaces not allowed in names. So you can't say int and then space my age. You can't do that because that's not allowed in C. And $, not allowed. So, or any special characters for that matter. So only letters, digits, and of course semicolon allowed in our variable name. And of course the last one will be the reserved keywords. You can't use reserve keywords. So that's basically, so for example, you want to name a variable int main, something like that. You can't use this variable name because this is a reserved keyword, meaning it is a primary keyword used by C, as you can see here. So now let's talk about the four major four basic data types in C. So there are four basic data types in C. That's int, and then we have char or characters, and then float, and then we have the double type. Okay, so int is a type that stores integers in the form of whole numbers. So any number that is whole, so you can say it like int age equals 10, or maybe 11, 20, for as long as it is a whole number. So it should be a whole number between 2,147,468 or 648 something. So negative, and that's inclusive. Positive for 2,147,483,647. So that's the length of the int if you want to use this particular type int. So that's the int should be between that number or those numbers. So the next one is the char type. So char is just a series of character or a single character. So the way of declaring a character or a char is you have to use char keyword, and then, so for example, letter 1 equals A. There you go. You have to enclose it with single quote, and it signifies that it is a single character or something like that. And of course, you can have like a series of characters. So for example, like what we have previously, char and then character name. And then you have to use the square brackets for that matter. And so for example, John. Okay, so that's basically how to declare or how to use the char keyword. Okay, and the next one is float. So basically, float is a short for floating point, and it stores representations of real numbers, both integer and non-integer values. And the way on how to declare that is by using the keyword float. And then maybe you can declare it as float pi equals 3.14, something like that. So you can declare your float values by using that keyword float, and then followed by the keyword or the variable name, which is, for example, in this case, the pi, which is 3.14. Okay, and of course we can use also the data type double if you want. So double is, so for example, salary equals 10,000, something like that. And basically, if you want to use double, all you have to do is use this keyword double and then the name of your variable name, so in this case salary, and then declare or initialize it with a double value, something like that. Okay, and if you have any doubts to the amount of memory actually used by any variable, you can use the size of operator to find out for sure. So you can like use the keyword size of, and then the variable age. Okay, so for example, for that you can get the actual amount of memory allocated in that particular variable. And in this video, guys, we're going to talk about the scope of a variable, and of course we're going to talk about the operators in C and how we can use them. So let's go ahead and talk about the scope of a variable. So basically, a scope is a region of the program, and the scope of variable refers to the area of the program where the variables can be accessed after its declaration. So basically, in the C program, we have like three different scope or different location that we can declare our variables. So the first one is inside a function or a block. So we have the first one will be the local variable. There you go. We can declare a variable inside our function. The second one will be the global variable. Okay, and of course we can also declare a variable inside the function parameter. So function parameters. Okay, so that's all the area that we can like declare the variables and set the values to it. So but basically we do have like only the two
that is most common, although we are most of the time setting the function parameters and declaring variables to it, like almost every function. But yeah, the most common way of declaring a variable is the local and global variable. So again, when we say global or local variable, it is a variable that is declared inside a particular function or a block of function. So variables that are declared within the function block and can be used only within the function is called local variable. So this is how we can um, implement this in our C program. So for example, in here, we're going to declare. By the way, guys, this is a um, comment, and the way to make comment in C program is by using the double slash. So this means this is a single line comment, and of course we do have the slash and then the asterisk and then asterisk and then forward slash. So this is multi-line comment, so we can like add comments in between these lines, and this double slash will be the single line comment. Okay, so I hope you get the idea of these comments, and basically guys, these comments will not be interpreted by our C program. Okay, so as I've said, we're going to discuss, or we're going to declare a local variable here. Local variable definition and initialization right there. I'm just going to remove this single line comment. Okay, so the the way to declare a variable in C is like int, or this is the type of information that we want to save. So int, and then so for example, the variable name is x, and we can do it like this, y, and then z. So basically what we're doing here is declaring three variables of int type. Okay, so this is the variable definition, and of course we can initialize it by saying x equals to 10. Okay, x equals to 10, and y equals x plus 5, and then we can also say z equals y variable plus 1. Okay, so that's how we can declare a variable and initialize the value into the variable. So this is the definition, int x, y, z, and then of course the actual initialization, which is right here, x equals to 10, y equals x plus 5, and then z equals y plus 1. Okay, so of course you can always print this. So for example, printf, and then value of so for example, z equals percent %d. Remember, percent %d is just the placeholder for our integer value. So the value of z equals the c variable. Okay, and then save, and of course you can compile or build and run your C program. So let's try that. Okay, so we need to add the semicolon at the end of the line to mark that it is ending in this particular line. So build and run, and there you go. The value of z equals 16 because we set the x equals to 10, and then the y equals to x plus 5, and of course z equals y plus 1, that will result to 16. Okay, so that's how you declare and initialize a local variable. Now let's go on with the global variable or global scope of a variable. So variables that are declared outside of a function can be accessed inside the function is called global variables. So for example, you want to declare a global variable, all you have to do is before the int main function, okay, right here we can declare the global variable, okay, and we can declare it like int age, and then we have like the semicolon at the end of the declaration, okay, int age and then semicolon. So global variable initialization, so after defining a local variable, the system or the compiler won't initialize the value or any value to our local variable. So we have to initialize it by ourselves like this. So if we try to define the variables right here, it won't have any initialize or initial value. So we have to declare it like this: x equals to 10, y equals x plus 5, z equals y plus 1. But global variables get initialized automatically by the computer, or as by the compiler. And so for example, if we declare the variable type as int, then the initial default value will be 0. Okay, remember, you have to remember that. So the difference between global and local variable is, um, whenever we declare the variable in our local scope, it won't get any initial value, so we have to initialize it by ourselves. But the global variable is initialized by default, depending on the type of value that we have saved in our variable. So for example, int, then it will default, or initial default value will be 0. And if char, so for example char t, so the default value will be single quote and then backslash 0 and then backslash, I mean single quote. Of course, when we say float m, so the initial value of that is equal to 0. When we say double, the initial value of that is also 0. And when we say pointer, the initial value of this is equal to null. Okay, so you have to remember that whenever you declare a global variable, there is a default value for our variables. Okay, so as I've said, global variables can be accessed inside our main function or any function. So because this is a global variable, right? In this video, guys, we're gonna talk about the input and output in C programming language before we dive into operators and how we can use operators in C programming language. So basically, we can use the function printf to display something in our screen, just like what we have before. So printf, and then we can say hello world. Okay, and then we can build and run this program, and we can get the hello world string right here. We use the printf function for that. And now we're going to talk about the input, because we're trying to focus on the input because we're already familiar with the output side of C programming. So we have used the printf to output something in our screen, and then of course, in order for us to ask input from the user, we're going to use the scanf function. Okay, so the way to use scanf function, we can say here, we can ask for a particular number. So please enter a number. Okay, and then we can add the escape character here for a new line. and we can declare a variable here. So for example, int a, and then we can get the value from the user by using the scanf function, and then format specifier for our int variable or int value, and comma, and then of course the and symbol and the name of our variable a. So basically what this means is that we're taking the address of variable a and then assign a value to that address, whatever the user has inputted. Okay, so and then we're going to end this with a semicolon, and let's try this. Let's try to display the value that comes from the user. Okay, so the number is %d, format specifier for our int value, and then comma, and then the name of our variable, which is a. Okay, and then semicolon. So remember to end every time or end every line with a semicolon. Okay, and then we can build and run this application. So there you go. The program is trying to prompt us to input a number. So for example, number 5. So number 5 is, or the number is colon and then the value 5, which is coming from the user itself. Okay, and now we can actually ask two numbers in the same line by using also the scanf function. So in here we have like ask for a single number, but what we can do is we can ask for two numbers, just like please enter any two numbers. Okay, and then we're just going to use the same function percent scanf, and then %d, percent another %d, because we're asking two numbers. And then in here we can say and symbol and then the value or the variable b, which we will declare here on the top. Okay, b, and then we can declare another variable c, and we can add the values or the numbers coming from the user. So the number or the value c or the variable c, we can assign a value to that, which is the total of the two numbers a and b. So that will be c equals a plus b. So what we're doing here is that we're just assigning the value of the total of a and b into our c variable. Okay, so the total number is, and then %d, and of course the value of our c. Okay, which is again the total of our variables a and b. Okay, so save this, and then we can build and run our application. So please enter any two numbers. For example, 1 and 2. So the total number is 3. Okay, so again, like 5 and 3. So the total is 8. Okay, so as you can see, we are getting the two numbers 5 and 3, and then we're displaying the total, which is 8. Okay, so basically that's how you can ask or input something into our program, because our program right now is asking for an input from our user. Okay, and that's where we can apply the operators in our C program, and we have different operators or type of operators in C. So C programming language offers various types of operators having different functioning capabilities. So the first one is the arithmetic operators. So we have used the addition operator right there by, assigning the value of a plus b into c. Okay, and then we also have the relational operators. Okay, let me resize this so you can clearly see it. Arithmetic operators, and then we have relational operators, and the third one will be logical operators. The fourth one is assignment operators, and fifth one will be increment and decrement operators. I'm just gonna list it here so you can see all the type of operators in our C programming language. So decrement operators, and then we also have the conditional operator. We also have bitwise operators, and then we have special operators. So these are all the types of operators that we can use inside our C programming language. And of course, the first one is arithmetic. So arithmetic operators it includes addition. Of course, the symbol for that is the plus, right? And then we also have subtraction. Symbol for that is dash. We also have multiplication, and we can use the asterisk for that to multiply two numbers inside our C program. And then of course we do have the division, which is the forward slash symbol. And of course we have the modulo, and we can use the percent sign to operate by using modulus. Okay, now let's talk about the operators or arithmetic operators. So for example, addition. So we can also like int b equals a minus b. Okay, and then we can like have, of course not, we cannot redeclare it the b because we already declared it there. So we can say it d equals a minus b, and then we can see e, and then a times b, and of course we can have the division, and we're going to have like use the float, or we can use the double for that. Double f equals 1, or a divided by b. Okay, so these are the all arithmetic operators that we can use inside our C program. So basically, you can add, you can subtract, you can multiply, and you can divide two numbers inside your C program. So for example, we're going to test this. Okay, so int d equals a minus b. Okay, so we can display the total number is percent %d, and then the difference of the two numbers, the difference is, of course, we're going to use the different, or the variable D for the difference, and then we can use another one, which is the product. The product is percent D, and the next one is the quotient. Okay, the quotient of two numbers is, of course, the variable f, and then we can use the format specifier, which is lf. Okay, and then of course the variable f, something like this. So let's run our program. Okay, and we can enter two variables here, or two numbers, which is, for example, 5 and 3. Okay, so the difference, or the total number is 8. The difference is 2, and we need to format this so we can see clearly. So we can add percent, or I mean \n for each line, the difference, the quotient, and of course we need to have the product. The product is percent %d, and then of course the variable e. Okay, so again, run our program, build and run, and then 5 and then 3. So the total is 8, or 5 plus 3 is 8, and then the difference is 5 minus 2, or 5 minus 3 is 2, and then the product is 15. 5 times 3 is 15, and then the quotient is 1. Okay, so there's only one 3 in the value 5. Okay, and in this video, guys, we're gonna talk about how to use increment and decrement operators in a C program. And later on, if you still have time, we're going to discuss, or we're going to start discussing relational operators and how we can use inside, or how we can use it inside our C program. Okay, so basically, guys, increment and decrement operators are useful operators, and it is generally used to minimize the calculation. So let me show you an example. So in order to increment a value inside a C program, we do it like this: plus plus, and then the name of the variable. Let me do it here so you can see it clearly. Plus plus, and then the variable. Okay, plus plus, and then the variable. So it means that x equals x plus 1. Okay, remember, plus plus x means x equals x plus 1. And of course, in the same manner, when we say minus minus x, it means that x equals x minus 1. Okay, so this is how you increment and decrement a value inside a C program. But there is also a way. It is called the postfix. It is postfix because we place the operator, or the plus symbol, after the variable x plus plus. But it also means that x equals x plus 1. And of course, when you say x minus minus, still it means x equals x minus 1. Okay, so you get the idea. This is how you increment and decrement inside a C program. Okay, now there's a difference, or a slight difference, between having plus plus x instead of x plus plus, or minus minus x instead of x minus minus. Okay, so I'm going to show you that in a simple program. So basically, what we're going to do here is we will have a two variable. So two variable, which is a, which is equal to 5, and then b, which is equal to 5 also. So I'm going to show you the effect of postfix and prefix. Okay, so again, this one is the prefix. Okay, and then this is postfix. Okay, so let's comment this out. So I'm going to show you the effect of postfix and prefix in this particular example. So int a equals 5 and b equals 5 also, and then in here we set the value of a and b equal to 5. Okay, so basically what we can do right now is print and decrement each time. Okay, and then we can use the variable a for our postfix. Use a for postfix and use b or variable b for prefix. Okay, so we can do this by using the printf method, and then um, \n and then %d. Okay, and then %d, because we're having to display, or we're going to display both the value of a and b. Okay, so we're going to use the postfix here, a minus minus, and then this one is for minus minus b. So again, this is postfix and this is prefix, and then they are set or the value of these two variables are set a equals to 5 and b equals to 5, and then we can end this with a semicolon, and of course we can do the same. We can do another one, and 1 2 3 4 5 6. There are 6 lines. So we only need 5, and I'm going to show you and demonstrate what is the effect of postfix and prefix. So for you to understand, here we have taken the value of a, and then of course taken the value of b, and then we apply postfix and prefix. So if you try to run this, build and run, as you can see, the value is 5 4 3 2 1, and the value of b is 4 3 2 1 0. So it means that if we use the prefix, okay, which is the case here, minus minus b, so it automatically decrease the value of our variable by 1, whereas here it displays the value of a still 5, and then later on 4, and then in the third line 3, the fourth line 2, and the fifth line is 1. Okay, and then of course in the prefix it decreased the value by 1, and then 4 3 2 1 and 0. Okay, so that's how you do it, the increment and decrement in a C program, and this is quite useful if you are working with for loops, which we will discuss later on in this particular series. Okay, now let's move on to the next operator, which is the relational operators. If we have increment and decrement, we also have the relational operators. So basically there are like 1 2 3 4 5 6 relational operators, and the first one is equal equal. Okay, So basically, we're just checking if something is equal to, or a variable is equal to some variable. Okay, is equal to, and then we have the exclamation point and then equal. So it means is not equal. So basically, by this, we're just checking if a certain value is not equal to another value. And then, of course, we do have the greater than. Okay, greater than. And then we have less than. And then, of course, we have the greater than or equal to. So greater than or equal to, and less than or equal to. Okay, so basically, um, we're just checking the relationship, or like the relation between two values, if it is equal, if it is not equal, if it is greater than, less than, or these two comparison or relational operator, greater than or equal to, or less than or equal to a certain value. Okay, and then of course, we can use this especially in a if statement, in and we're going to discuss that later on in this particular series. So basically, if you want to check if something is equal or not equal or greater than, then we can use the relational operators. So we have to remember this. This is one of the most important concept in programming. So the relational operators. Okay?
And in this video, guys, we're gonna discuss about the logical operators and of course the assignment operators. So previously we have discussed this relational operators. So we have like 6 relational operators, the equal, or checking if a value is equal to some value also. And then not equal, we have also greater than, less than, and then we also have greater than or equal to, and we also have less than or equal to some value. So this is quite useful, guys, if you are using the control statement in C. So for example, if statement, and then you want to check if a certain value is equal or not equal to some value. So for example, if a variable x is equal to 2, so basically we're just checking if this particular variable or the value of this x is equal to 2. Or we can reverse that, we can check if this particular variable is not equal to 2. And of course you can use other operation or operators like greater than, less than, or we could also double check for greater than or equal to, or less than or equal to. So basically, guys, these operators is like just checking the relationship, or if the certain value is greater than another value, or it is equal to another value. Okay, now let's move on to the next one, which is the assignment operators. So basically, guys, there are a lot of assignment operators in C programming language. Okay, so the first one will be the equal sign. Okay, this is one of the most common assignment operators in C programming. So for example, you want to assign, so as I've said, guys, this is for assignment operators. Assignment operators. Okay, so basically this is useful if you want to set a value to a variable. Okay, so for example, x, and then if you want to make this like 5, or the value of x is equal to 5, you can do that by using this particular assignment operator equal symbol. Okay, that's easy. And the second one is plus equal. So we have this also, plus equal, and then it basically means, guys, that it increments the value
and then assign it to the variable. Okay, so for example, you want to make this like x and then plus equal to 2. So basically, let's try this. We can remove this code right here. We can use the increment, then assign. So basically, like we set a value for x, we set it to 5, and then we can have it like x plus and then equals to 3, and then we can use the printf function and we can display the result further. So for example, the value is the format specifier, and then of course the comma, and then the x variable. Okay, and then semicolon at the end of this line. Save this and then compile and build, or build and run our application. So basically, as you can see here, the value is 8. So this is the doing of the plus equals to 3. So basically what it means that it add 3 to the variable x, and then of course the result of that is assigned to variable x also. Okay, so this is basically just incrementing the value of our variable. And of course we also have the x minus equals to, for example, 1. Okay, so basically it is the complete opposite of this one, because this is for incrementing and this is for decrement. Okay, and of course we do have other operators for this particular topic, which is the assignment operators. We also have x, for example, times or multiply equal to 2. You can also do that, and basically the division also. Okay, you can do also the modulo part, modulo symbol, and then equal, and then so for example 2, and there are others. So for example, percent, or I mean x, and then and symbol and equal symbol, and then of course the value that you want to assign. So this is basically bitwise and assignment. So we're not gonna use that for now. So basically our currently concern is this operations. We can have the increment. The first one is equal, and then of course the increment, the decrement, and then multiplication, then assign. And we also have divide and assign. We also have modulo and assign. So that's basically how the assignment operators work. So the last thing that we want to discuss here is all about the logical operators. So logical operators provides 3 mechanism that we can test more than one condition to make a particular decision. So these are the and symbol. So meaning it is logical and. Okay, logical and. Let me show you that later on, what this means. Logical and of course we also have this bar, and this is logical operator or logical or. And then of course we have the negation or not symbol. Okay, so logical or, and then this is and of course logical not. Okay, so let me show you how this works, these 3 logical operators. Now let's try to use the logical operators. So for example, the first one, the logical AND operator. So we have here variable x, which is set to 8, or the value is 8.
and then we can check if this particular value is, or the particular variable x is greater than 5. So we can do that by using the if statement, and then x, is it less than or greater than 5? So if x is greater than 5, then we can display something in our screen or output something. So we can do printf, and of course the value is greater than 5. Okay, so we could build and run this and see the output of our program, and of course it's gonna display the value is greater than 5. Okay, so what if the value is 4? Okay, so obviously there will be no output because the condition right here turns to be false because the actual value of x is now 4. So no statement has been executed for this particular program. Now we can use logical operators and in this particular scenario. So for example, we want to check that the value of x should be greater than 5 but less than 10. Okay, so we could check if the variable x is greater than 5 but less than 10, and we can do that by using the logical AND operator. So double ampersand and x and then less than 10. Okay, we could do that, and of course if we try to run this, still there's no output because the value of x is 4. So we can try 6 here, build and run our application. So the value is greater than 5, and we should add here that the value is less than 10. Okay, build and run our application. So the value is greater than 5 and it is less than 10. Now what if it is 11? So obviously it's going to display nothing in our screen because the conditions of this particular statements is not met. Okay, so that's how you can use the logical AND operator. And of course when we say AND, basically it means that it should be both of this statement or both of these conditions should be true in order for this statement to be executed. Okay, and you can also use the logical operator OR in this particular scenario. So it doesn't matter if the x is greater than 5 or x is less than 10. It should, execute the statement that we have here. Okay, so for example, we run this. Okay, so we have the value is greater than 5 and less than 10, and we can try like 20, or maybe use the value 20 in our x. So let's try this, save, and then build and run. Okay, and as you can see, we still have, or we still get the output, the value is greater than 5 and less than 10. That's because this particular statement here returns true. So it doesn't matter if this particular statement here is false. So as long as there's a true, returns either of this statement. So there should be statement printed or executed inside this particular if statement. In this video, guys, I'm going to show you and teach you how to use if statements in C programming language. So I think from the previous video we have touched the basic usage of if statement. So we have tried the if statement with the logical operators.
So the and, the relational operators, the greater than, less than, or less than or equal to, and other relational operators. Okay, but in this particular video, guys, I'm going to go deeper with the if statement and how we can apply if statement in our C program. And of course, guys, I want to show you the practical approach on how you can implement if statement in a C program. So basically, guys, if statements in C is used to control the program flow based on some conditions. So it is used to execute some statement code block if the expression is evaluated to true. So otherwise, it will get skipped, and we will try to implement a simple or basic program utilizing the if statement. So actually, guys, there are 4 different types of if statement in C. So these are, simple if statement. We also have if else statement. We also have nested if else statement, and we also have else if ladder in C programming language. But for now, let's just focus on the simple if statement. So basically, the structure of if statement is just like this. So we have this particular format or basic format of if statement in C. We have if keyword and then open and close parenthesis, and then inside of this open and close parenthesis is the test expression, okay, or the condition. And then of course we should add curly braces, open and close curly braces, and then of course the statement to execute whenever the test expression or condition is met, or in this particular case, if this particular condition is evaluated into true. Okay, so now let's try to implement a practical approach of an if statement. So say for example, you are developing a program or a software for a particular bar. Okay, and then that particular bar only accepts customers that are over 18 years old, and those customers that are below 18 years old are not allowed to enter the establishment or the bar itself. And we can create a very simple program for that, and our program will accept the age of the customer, and then it will evaluate the age and it will display a message based on that particular age. So the first thing that we're going to declare here is the variable age, which has the type of int, and of course we need to display something on to the screen that says to input a number that pertains to the age of the customer. So in order for us to do that, we need to use the method printf, and then in here we can say enter the customer, or enter the age of the customer. Okay, then we can add colon and then space, so we can have like this space for our input age. Now we have this output, and we need something to accept a number from our user, so we can use the method. I think we already used this before, the scanf, right? So in here we need to specify the format specifier for our age, which is %d, which pertains to the values that are of type int. Okay, and then of course after this we need to add the comma, and of course the variable age, and of course we need to end this line with a semicolon. But the proper way of doing this is to add an ampersand symbol. Okay, so basically what we're doing here is just we're getting the address of age and assign value of that particular address using the value that has been inputted by the user. Okay, and of course we can now apply our if statement with this particular age. So the first thing that we're going to check if the age is greater than 18. Okay, so we can just copy and paste this age variable, and then we can add the logical operator greater than. So basically what we're doing here is to check if the age is greater than 18. Okay, so there you go. And then of course the statements to execute if condition is true. Okay, so basically what we can do here is to print the age is greater than 18. Okay, and basically it says, or it means that the customer can enter the premises or the bar itself. Okay, and of course we can also check if the user or the age of the customer is equal to 18. Okay, we could also check that by using the logical operator or the relational operator equals and equal symbol. So this is just testing the age if it is equal to the value 18. So the first one is we're testing the value age if it is greater than 18, and the second one if it is equal to 18. And then of course we need to display the corresponding output. So the age is equal to 18. Okay, and then of course we can add another one for this. So we can just copy and paste. For this one, we need to check if the age is less than 18. So this is another logical operator that we have discussed from the previous videos. Okay, so greater than, equal, and then of course less than 18. And of course we can output here like minor is not allowed. Okay, that's because the age of the customer is less than 18. And the general rule when it comes to bar is minors are not allowed. So basically what we're doing here is a very simple program for that particular bar. Okay, now we can try to run our program. We can just build. Okay, and then we can run our program, and we can enter the age of the customer. So for example, the age of the customer is 18. So the age is equal to 18. Okay, so as you can see, this is the only output, or this is the only statement that has been executed, the age equal to 18, because the other one, the other condition is not being met or not evaluated to true. Okay, because the age is equal to 18, and of course this is greater than 18, and of course this is less than 18. So we can try another one. So for example, the age is 19. So the age is greater than 18, and of course again this is the only statement that has been executed, because the condition evaluated to true. This is evaluated to false because the age is not equal to 18, and this one is evaluated to false also because the age is not less than 18. Okay, so you can try this one more time to check for example, the age of the customer is 16. So the output is the minor is not allowed. Okay, that's the practical way of using if statement in C programming language. In this video, guys, we're gonna talk about if-else statements, and of course we're going to discuss also the nested if-else statements in C programming language. Now, from the previous video, we have created a simple application. So we have assumed to create an application for a bar or establishment, and then that particular program will ask for the age of the customer that is trying to enter the premises of the bar. And of course, we ask for the age, right? And we check for the age. If it is greater than 18, then we display the age is greater than 18. And if the age is equal to 18, and we also display the age is equal to 18. But in case that the age is less than 18, then we print that minor is not allowed. So basically, guys, this is a good program, but we can, upgrade this. This is not, when it comes to code readability and code maintainability, this is not a good practice when it comes to checking a variable or a certain value of a variable. So now let's just remove these lines. Okay, and of course we have this first condition if, and then we check for the age of the customer, which is 18. So if the age is greater than 18, we display the age is greater than 18. So as I've said, we can take this further by adding else statement right here. So basically, the if else statements in C is also used to control the program flow based on some condition, and the only difference is it used to execute some statement code block if the expression is evaluated to true. So it will try to execute this particular statement if this particular condition is true. Otherwise, it will try to execute the statement of this particular else code block. Okay, so in here we can try to display printf the age is less than or equal to 18. Okay, so as you can see, if we try to evaluate this, so if age is greater than 18, so for example you have like 19 or you inputted 19, then of course automatically it will execute the statement that the age is greater than 18, right? Now basically if we try to input 18, so 18 is not greater than 18, so it will try to execute the code block or the code or the statements inside this else code block, because the condition right here returns false. Okay, because 18 is not greater than 18, and there you go, it returns false. Okay, now we can also add another condition right here. So for example, we want to check if the age is equal to 18. Okay, we can check if the age is greater than 18, and of course we can also check if the user or the age is equal to 15, and then otherwise it is less than 18, and we can add another else statement right here. But for now, let's just add the another condition or condition evaluation test expression if the user or the age is equal to 18. Okay, so basically this particular statement, if this particular condition right here is false, then it will try to evaluate one more time with this particular condition. Is the age equal to 18? So if that particular age is equal to 18, then we can display the age is equal to 18 right there. But in case if the age is less than 18, we can also add the else statement right here,
and we can display that the age is less than 18. Okay, so as you can see, we have implemented a practical implementation of if else statement, and we can add the first if condition, and then we can add another condition else if, and then we can test this condition right here. Otherwise, if these two conditions are returning false, then we can execute the statements in this particular else block. Okay, so we can try this. We can run our program, build and run. So let's try first the possibilities. So for example, the customer, or the enter the age of customer, for example 25. So the age is greater than 18. So let's try to run this once again, and we can try to input 18. So the age is equal to 18. Okay, so this particular condition right here returns true. Now we can also try to input a value which is less than 18, so for example 16, and then of course the age is less than 18. Okay, so as you can see, in this particular example, there will be only one block of code that will be executed. So for example, this one, if this will return true, the age is greater than 18, then it will execute this statement right here, or inside this if block. Then it will ignore the other like the else if and the else. Now if it will return false, then it will try to evaluate the expression inside here, and if it is true, or it will return true, then it will execute this statement and ignore the else. If all of these statements or conditions here will return false, then the else statement will be executed. Okay, and it will try to print the age is less than 18. Now there are cases that we need to check also. For example, inside this if statement, we want to check if the age is less than 25. Okay, less than 25. Although we have like the age is greater than 18, we want to check also if the age is less than 25. So we could add also if statement right here. So this is like what we call nested if else statements. Okay, nested if else statement. So we can also check here if age is less than 25. Okay, and then we can display here printf, and then the age is greater than 18 but less than 25. Okay, less than 25. And of course we can also add else statement here, or else if, like for example, else if the age is greater than 25, then we can say here printf the age is greater than 18 and greater than 25. So there are cases that you want to check this, if you want to, like in the future, you want to implement an application and you will try to check the values, and somewhere in your code you need to check like the value age here, and also you could also check if the value is less than 25 or greater than 25. So it is very useful when it comes to programming this particular nested if else statement. So let's try to run this, and before that I'm just going to add a
\n right here, so that we will have a new line after this particular code execution. So let's try to build and run our app first and try to input a value that is over 18. So for example, 23. So the age is greater than 18, and there's another statement that has been executed right here. The age is greater than 18 but less than 25. We can also, run this once again and input 26. So the age is greater than 18, and there's also a statement here, the age is greater than 18 and greater than 25. Okay, and that's how you use the if-else statement, or if-else statements in C. And then of course, if you have like many conditions that you want to check, so you can also add another conditions right here. Okay, and then another condition, and otherwise, if these conditions are not met, then you can display or execute the statement inside this else code block. Okay, now the nested if else statement requires only one if. Okay, so you can't use like two ifs here, because it will try to separate the chain of if else if you use another if. So what you can do is one if, and then else if, and also one else statement. So it doesn't matter how many else if statement that you can add, okay, for as long as it is like has one if and has one else statement. Okay, so and in this video guys, we're going to learn how to use ternary operators in C. So basically guys, the ternary operator is used to execute code based on the result of a binary condition. So when we say ternary operators, it is used to execute code based on binary condition. Okay, and it takes in a binary condition as input, and which makes it similar to an if-else control flow block. So for example guys, from our previous tutorial, we have discussed how to use if-else statement. Okay, so we have this kind of structure. So for example, we want to use this structure or code to get the maximum of two values or two variables. So if you want to like return the max value, all you have to do is compare the two variables A and B. So for example, if A is greater than B, then of course A or max will be assigned to A. Otherwise, the max number will be the value of variable B. Okay, so the ternary operator guys, instead of using if else like this is too long for a simple checking of value condition. So the binary or ternary operator uses only single line, or we can use the ternary operators in a single line, and it returns a value, so behaving similar to a function. Okay, so let's try to see the syntax of the ternary operators in C. So basically the syntax is like this: result, and then binary condition, and then you have to add the question mark, and then you have like the value when the binary condition is true, otherwise the value of value to be returned if the binary condition is false. So we have to take note, guys, that the ternary cannot be used to execute code. So it must be either return in a function or set equal to a variable. So you cannot use this like something like this. So you cannot leave your ternary operator like this. So it should be equal to or be set equal to a variable. Okay, something like this. Or you can use it as a return in a particular function. Okay, so let's try to implement a ternary operator. So for example, you want to check the max value. So the long version is this. If A is greater than B, then assign the value of A to the max, and then otherwise assign the value of B to the max variable. So as I've said, we can, make this a little shorter by using the ternary operators. So in order for us to do that, we just need to, so for example, get the variable max, and then the binary condition is A greater than B. Okay, so we can add the question mark. There you go, question mark, and then the value to be returned if the binary condition is true. So of course, if A is greater than B, then the max value is A, right? Otherwise, the value is B, or the return or the max value is the value of variable B. As I've said, guys, this is the explanation of conditional or ternary operators in C. So we have this variable, and then we have the expression or the condition, and then you have to add the question mark, and then the value if true. So it will return the resultant value into the variable, and it will assign this value to this variable. Otherwise, if the expression is false, then the resultant value of the false, then it will be returned as the value of the variable that we have added. Okay, so we can check this right now. We can remove this. This is the long version, and we can try to print this, display the result. The max value is, and then format specifier, which is we're using int, so %b, and then of course the max variable. Okay, let's just remove this. So clean and build, or build and run our application. So let's try this. We don't have like the value for A and B. So let's try to assign values to this variable. So for example, A equals 15 and B equals 16. Okay, so clean and build our application, and we'll try to get the output. So the max value is 16. Okay, so we have here the B variable 16. So that's the value of max variable that is being assigned, because this particular condition returns false. So that's why the value of B variable is being assigned to the max variable. So we can also try this with the other, if the A is greater than B, so like 20. So obviously A is greater than B. So let's try this. Exit this for now, and then build and run our application. So Let's try this. So there you go. The max value is 20. So this condition returns true because A, which is the value, is 20, and that's greater than B because B is the value is 16. So it returns the value of A. So like this. So it ignores the second part, which is the B, because it returns true. And then of course after evaluation, the value of A is being assigned to the max variable that we have here. So it printed out that the max value is %d and then which is 20. So let's try this one more time, just so you can see the output. So the max value is 20. Okay, so this is quite useful if we only want to check a certain value. So like if you're planning to use if else, then you might want to use the ternary operators, which is like this. So it will just save you time, it will save you of code space, and I think it's clear rather than using the if and else statement. So this is pretty straightforward when it comes to checking the value and assigning the value to the max variable. Okay, so you just have to remember that it cannot be used to execute code. You just have to set this equal to a variable, or you can use this as return value of a function. Okay, and in this video guys, we're gonna talk about the C goto statement. Okay, so far we have discussed the if statements and how it is used in C to control statement execution based on some conditions or decisions. Now, the flow of execution also depends on other statements which are not based on conditions that can, control the flow. And of course, C supports a unique form of a statement that is, goto statement, which is used to branch unconditionally within a program from one point to another point inside our C program. So although this is not a good habit to use, goto statement in C, but there may be some situations where we can use the goto statement, and it might be, desirable to make use of the capability of the goto statement. So the goto statement is used by programmers to, change the sequence of execution of a C program by shifting the control to a different part of the same program. So I think I have mentioned this before in our, tutorial series, that the execution of a C program is sequential. Like if you have statements from line 6 here, 7 and 8 and 9. So it will try to execute from line 6, 7, 8, 9, 10 sequentially. Okay? But, we have this goto statement to control that particular flow. We can go to a certain point of our program by using the goto statement. So basically, this basic syntax of goto statement is like this. We have this particular syntax of our goto statement. So we have this keyword goto and label. Okay, and then of course we need to add label at some point in our program. Okay, and of course the long version of this syntax is like this. Let me show you real quick. So we have like a few lines, and then we have the label, and then we have the statement. Okay, and every time the program meets or found the goto statement, so it will try to find the label that has been specified in this particular line. So go to label, and then it will skip the lines or statements between or other statements, and it will go directly to the label
and it will execute the statements below the label in our C program. Now we can um, implement this, and of course guys, it can also be used to, this is a forward jump in our program because we have specified the goto statement and then it forwarded to the label statements below. Okay, but it could be also the backward jump of a program. So for example, after execution of some lines, it will jump into this particular label. So after execution, it will jump to this label. That's why it is called the backward jump in our C program. So for example, if you have like no other label available here, so it will jump the program execution from here and then go back to line 9. So that's how the backward jump inside our C program. So let me just clarify this. It is called backward if the goto label is here and then it will try to jump on top or the lines before that goto label, and it will execute all the statements under this. Okay, and it is called forward jump if the label is here. So after this, or after execution of this line, it will try to go to this particular line label and it will execute the statements under this particular label. So now let's try this and let's just build a practical or simple implementation of this goto statement. So let's just remove this, and then we can try to ask for an age just like what we have from the previous video, and then we can try to add the label. So for example, G, and this will be the label name. Okay, and then of course we have a statement under this particular label, so printf. So for example, we will try to execute this if the age is 18, so like you are eligible or something. Okay, then we can try to add the new line here, and then of course we can try to add another label, so another label name, and we can print you are not eligible. Okay, something like this, and we can also add the new line here. Okay, and then of course we do have the statement to ask for the age, so enter your age. Okay, and then semicolon, and then we can use the scanf function to get the actual value from the user. So %d, which is the format specifier again, and then ampersand and the variable name, which is age. And of course we can have the condition right here, like if the variable age is greater than or equal to 18, then we can use the statement go to the label G. Okay, and else we can go to the label S. Okay, now as you can probably observe here, we are using if else, but we don't have the curly braces, right? So you can do the if and else statement like this without the curly braces, because we only have one line in this particular, or after the condition we have only one line, and also else we only have one line. But if you have like 5 lines here, you have to add the curly braces. Okay, so in C programming, it like understood if there's like one line to execute, so there's no need to use the curly braces. Okay, now we can try to run this and see how it works. So for example, build and run our application and try to evaluate
and see how this particular program works. So basically, it executed line G and line S, right? So you are eligible and you are not eligible. Now, if we try to go or input number 18 right here, so it will try to uh, execute again the line 9, 10, 11, and of course it's gonna, ask for the age again, right? So it starts from this particular line 9, which is the label G, because we have specified if the age is greater than or equal to 18, then it will try to go to label G. Now, if we try to go to or input 16, so it will try to go to label or line 11, which has the label S, right? And it will just display you are not eligible, and it did not execute the statement from line 9 or line 10. It directly go to 11 line or line 11, which has the label S, and then it printed out the statement you are not eligible, and also it also adds asked the age again, and then it asks for the input from the user. Okay, we can try this one more time. So for example 15, so it's going to execute all the lines starting from line 11 with the label name S. Okay, so guys, as I've mentioned earlier, that the goto statement is a unique form of statement. Okay, and sometimes it is not advisable to use goto statement in your C program, but there are situations or conditions that you might want to use this particular goto statement. So for example, if you want to skip some of the lines in your program, so let's try that. Okay, so like for example, you have statements like this, printf, and then this is the end of the program. Okay, and then we can go like, instead of using S, we can add a label here, E, and then it will execute, E instead of S. So basically, after this condition returns false, then it will execute this, and it will call the label E, and then execute that. This is the end of our program. So let's try that. Execute or exit our program first, and then build and run. So let's try to input first 18. So it's going to execute from line 9 until line 15, and then if we try to input 10, then it's gonna say this is the end of the program. Okay, so I think that's all there is to it in this tutorial, guys, and I hope that's clear on how to use the goto statement in C. So again, this is quite useful in some situations, and in this video, guys, we're gonna talk about loops in C programming. So sometimes it is necessary for the program to execute the statement several times, and C loops execute a block of commands in a specified number of times until a condition is met. So in this video tutorial, you will learn about all the looping statements of C programming and along with their use. So as you can see, computer is the most suitable machine to perform repetitive tasks, and it can tirelessly do a task tens of thousands of times. Okay,
And basically, like every programming language has this particular feature to instruct to do such repetitive tasks with the help of certain form of statements. So that's why we have this loops. And then of course guys, in C, the C programming language supports like three types of loops. So we're going to discuss first while loops. Okay, so we have while loops, we have do while, and of course we also have the for loops. Okay, so we're going to dissect each type of loop so that we could better understand how it works and how we can use these loops in a certain situation. So basically guys, when we say loop, I'm just going to show you a simple flow chart. So we have here a simple flow chart that describes the nature of loop or loops in general. So we have like start, and then we can declare a counter or a variable counter, and then our program will try to evaluate the condition. And then if the condition is returns true, it could execute statements and then increment the counter, and then again evaluate the condition. If the, like for example, the increment counter is equal or greater than something, and then execute statements, increment counter, and then evaluate condition, and lastly, if the condition is met, then it will stop the execution of that particular loop. So basically guys, a loop is just doing or executing repetitive statements inside our C program. So there are like control statements, we have statements that we can use. So we have break, we can have like continue, and then of course we have the goto statement that we have discussed previously in our video tutorial series. Okay, so as I've said, we will discuss first the while loops in C programming. Okay, so C while loops statement allows to repeatedly run the same block of code until a condition is met. And of course, while loop is the most basic loop in C programming. And while loop has one condition, and it contains or it executes as long as the condition is true, and then the condition of the loop is tested before the body of the loop is executed. So the syntax for our while loop is like this. So we have the keyword while, and then a condition, so like a test expression, and then if this condition is like true, then it will try to execute the statements inside this particular while loop. Okay, now we can have a very simple application for this. So for example, we will try to implement this. Okay, so we can declare like a variable, so int n equals 1, and then times equals 5, and then of course we can declare the while loop for our program like this, and then open and close parentheses, and then we can say n is less than or equal to times. Okay, so we have to add the curly braces for that, and then inside these curly braces, these are the statements that will be executed if this particular condition is true. Okay, so it will try to print like C while loops, and then we can add the percent %d, which is the format specifier for our int variable, and then we can display the n. Okay, and then of course we can increment the value of n by using the increment that we have discussed before, which is n plus plus. So basically this is just, you know, basically saying n equals n plus 1. Okay, I think we have already discussed that, the n plus plus increment, in our previous videos. Okay, now we have set the value n equals to 1. Okay, and then we have set the number of times the loop should be executed. So that's basically 5. There should be 5 execution, and then we added the while statement and then check the condition. If n is less than or equal to times, then execute these statements right here. So we can try to check this, build and run our application, and try to see the output of our program. And I'm going to, slowly explain to you what happens in this particular program. So you can see the output right here. See while loops 1, see while loops 2, and then 3, 4, and 5. And after 5, it no longer executed because it, ended the loop. Okay, so I'm going to explain to you how we got this output. So first thing, as I've said, we declare n equals to 1. So in this condition, 1 is less than or equal to 5, which is the value of times. So basically, and of course it is true that 1 is less than or equal to 5. So that's why it executed this particular statement, see while loops, and then it displays the value 1 right here. Okay? And then it incremented the value n. So now the n becomes 2. Okay? And then it will go here in our condition once again. So 2 is less than or equal to 5. So that's true because obviously 2 is less than or equal to 5. So that's it executes this statement right here, see while loops, and then the value of our n, which is 2. Again, it incremented the n variable, so the n now becomes 3. So after that one, we will go back here in the condition is 3 equals, or I mean less than or equal to 5. So that's true because 3 is equal to, or I mean less than to 5. So that's why it printed the output right here, see while loops, and then the value of our n equals to 3. And now after that, it incremented another time the n, and the n becomes 4 now, and it go back to the condition is 4 less than 5. So basically 4 is less than 5, obviously. So that's why it printed out this see while loops and then 4, the value of our n. And again, incremented, added 1 to the n variable, and then the n now becomes 5, and then go back here in the condition is 5 less than or equal to 5. So it returned true again because 5 is equal to 5. So it printed out see while loops and then the value of our n, which is 5. Now it incremented another time the n variable, and now the n variable becomes 6, and it will go directly here in our condition is 6 less than or equal to 5. So it returns false because 6 is not less than or not even equal to 5. That's why it ended the loop and it never executed the this particular statements right here once again because 6 is not less than or equal to 5, which is the value of our times variable. So in this video, guys, we're going to discuss another type of loop, which is the do while. So from the previous tutorial, we already have discussed the while loop, okay, and then we implemented a simple iteration program
where we could see the value of the variable each of the iteration of our while loop. Now, the difference between while loop and do while is that the while loop will try to evaluate first the condition, and then if this condition is, returned true, then it will execute the statement inside this particular while loop. Whereas when we are trying to use the do while loop, then the statements inside the loop will, execute at least once before the condition is being evaluated. So the syntax for that is like this. We'll just remove this for now. All these lines of the while loop from the previous tutorial. Okay, so this is the format or basic format of the do while statement or do while loop in C. So basically we have the do keyword and then open and close curly braces and then the statements or group of statements. Okay, now after the curly braces, then it will have the while keyword and then open and close parenthesis with the condition inside it. So as I've said earlier, guys, that this particular loop will try to execute at least once before the condition is being evaluated. Okay, so as you can see, if you wanna like execute first some statements before you could evaluate the condition, so the do while loop is the way to go. So we will try to create another program, guys, showcasing how this particular do while statement or do while loop looks like or how it works. So basically, guys, we could initialize some variables here. So for example, the n. So int n equals 1. And then we could also declare another variable, which is times. So basically what we are doing here, or what we're declaring here, is two variables for our do while, and the n represents the number, or I mean the value of the iteration, or the value of the variable each iteration. And then of course the times is the number of times the loop should execute. Okay, now inside our do while or do statement, we could add a printf statement here, and then could say C do while loops, and then the format specifier %d \n, and of course the n variable. Okay, so we have this printf statement. So basically what we're trying here is we're trying to display the value of n every execution of this particular statements. Okay, and in here below this printf statement, we could increment the n by using this statement, n equals n plus 1, or you could simply use the n plus plus version of this particular statement. So n equals n plus 1. So again, every iteration we would try to increment the value of our n plus 1, and then inside here the while and then open close parenthesis, we could add the condition. So for our condition, you could add the n and then less than or equal to the number of times we want this while loop or do while to be executed. Okay, so I think that's all for this do while statement. So we could try to run our program and then build and run and see how this particular program works. Okay, so basically, guys, I will try to explain it to you how this, or how we got this output. So from the initial value of our n, we have executed the do statement right here. So we printed out like the value is c do while loops, then %t, and then the value of our n is 1. Okay, so after this iteration, we increment the value of our n by 1, so that's n equals n plus 2. Okay, or I mean 1, n plus 1, and then the semicolon. And then, of course, we will try to evaluate this in our condition. So 2 is less than or equal to times, which is 5. So, of course, 2 is less than 5. So that makes sense. And then it will try to execute the statements inside the this curly braces. Okay. Then printf c do while loops, and then of course it will try to output the value 2. Okay, after this, the n will be incremented again by 1, so n equals n plus 1. So the value now, or the n value now, becomes 3, and then evaluate it in our open and close parentheses. So 3 less than or equal to 5. So obviously 3 is less than 5. So it will try to implement or execute again the statement inside our curly braces, and then display 3. This will be the line 3. And then of course it will increment again the value n, and the n becomes 4 now, and then evaluated once again is 4 less than or equal to 5. So basically 4 is less than 5. So it will execute the statement printf again, display the value 4, and then increment again the n. It becomes 5, and then after that it will try to evaluate the statement is less, or n is less than equal to 5. So we have set now the value to 5, so 5 is equal to 5. So it will try to execute the statement once again, and the 5 value now becomes, or the n value now becomes 6, because we try to increment it here. So 6 will be evaluated inside our while statement. Then 6 is less than or equal to 5. So that's basically not true, because of course obviously 6 cannot be less than, or cannot even be equal to 5. So that's why it will try to end the loop, because the condition returns false already. Okay, so that's how the do while statement works. And guys, make sure that there's like a finite end of your loop, because there are cases that the condition will not be evaluated into false at some point in our program, so that will make it like the infinite loop. So the concept of infinite loop. So be careful to place a condition here that will try to, or like will be evaluated false at some point in our program, because you don't want to have the infinite loop, because the program will run infinitely, and you don't want that. It would consume the memory of your computer. So that's why you need to be careful with the infinite loop. So make sure again to add a condition that will be evaluated as false at some point in your program. And in this video, guys, we're going to discuss another type of loop, which is for loop. So from the previous tutorials, we have like discussed already what is while loop, what is do while, and how it can be used in our C programming or C programs. So as I've said, guys, in this video we're going to discuss for loops, and of course we're going to describe the syntax of for loops. Okay, so the syntax for loops, guys, is like this. I'm going to copy and paste this here. So we have here the for keyword, and then we have the open and close parenthesis, in which we can, there are like three statements that are available for us. So the first one is the init or initialize, and then the second statement is the condition, and the third one is increment, or it could be also decrement. Okay, so these three statements inside this open and close parenthesis is separated by semicolon. Okay, and of course guys, each of this statement plays a big role in our for loop. Okay, now we can try to implement our very simple for loop. So for example, let's declare a variable for our for loop. Inside the initialize statement, we could initialize a variable right here, like for example int x equals 0. So we could do that here. We could initialize our variable into something like 0, or it could be 1 if you want to start 1. So basically guys, it is the same as declaring the variable here. So int x 0. So you could also do that here. Initialize the value to x. So this two is just the same. So basically we're just declaring the variable and setting the initial value, say for example 0 or 1. Now the second statement for this particular for loop, we could add the condition. So the condition is something like this. We could check if the x variable is less than or equal to 5, just like what we have from the while loop and do while loop. So we're checking if the value of the variable is less than or equal to 5. And of course, the last part or the last statement for this particular open and close parenthesis for loop, you could add the increment, or it could be the decrement depending on the initialize the condition, of course, in your for loop. So for example, we want for now is to increment. So you could actually do this like this: x equals x plus 1 inside the for loop. And then of course guys, the statements inside the curly braces. So the statements, you could execute statements right here. So for example, printf the value of x colon, and then the format specifier %d \n to have a new line, then specify our variable x, and then end this off with a semicolon, just like this. So guys, basically what we're trying is to display the value of the variable x each iteration of this particular loop. So we could build and run this application and see how it works. Now we have this output. The value is 1, the value is 2, the value is 3, the value is 4, and 5. So guys, I'm going to explain to you how we come up with this output. So at first guys, we declare the variable x and initialize the value into 1. So now the value for our x is 1. Okay, so value of our x is 1. Okay, and then let me write first is equal, or x is equal or less than or equal to 5, and then increment. Okay, so for example, at the first iteration of this for loop, we have initialized the value into 1, or the value of x into 1, and then we try to evaluate the statement is x is less than or equal to 5. So of course x is less than 5, since the value of x equals to 5. So this returns true. Then it will execute the statement, the value of x, it should be x right there, is 1. Okay, and then after this, after execution of this particular statement, it will increment the value of our x. So at the second iteration, it will be 2. Okay, so of course 2 is less than 5, so that's basically the condition will return true, and then of course it will display the value of x is 2, and then another iteration 3, so 3 is less than or equal to 5, right? And obviously the 3 is less than to 5, so basically it will return true and then display this statement, and until the x will become 6. Okay, 6, and then it will evaluate is 6 less than or equal to 5. So basically this is false, and then it will terminate the loop, or it will end the loop itself. So that's how we got this output. The value is 1, 2, 3, 4, and 5. So this particular output, guys, is incremented. So the value of our x is increment, like 1, 2, 3, 4, and 5. But anyway, guys, we could, make it like 5, 4, 3, 2, 1, and we will initialize our variable x differently. So for example, let's try to revise our for loop, and we will start from 5. Okay, so the initial value of our x is equal to 5. And of course, we will check if, so for example, is x is greater than or equal to 1. So now we're doing the reverse of the increment. And of course, guys, you can, add the increment statement just like this, x equals to x minus 1. And of course, you can use the post increment that we have discussed from earlier videos in this particular series. So you could do it like this, x minus minus, and then we could, display the value of our x. Okay, so let's try this once again and build and run our application, and of course we're going to get the reverse output. Okay, so we have here the initial value 5, and then 4, and then 3, and then 2, and then 1. Okay, so guys, of course you can always try to, add another for loop inside this loop. So as what we have from the previous tutorials, we have like the nested if and else statement. And of course, guys, you could also have nested for loops or nested while loops in your program. So for example, like this, you could, add another for loop here. So for example, int y is, we will set the initial value to 1. Okay, initial value into 1, and then we could try to evaluate the statement. So for example, is y less than or equal to x, something like this, and then we could add the increment y plus plus. Okay, and then open and close curly braces, and then of course we could display the value of our x and y. So the value of x, for example, %d, and value of y is something like this. The value of x is %d, and then the value of y is %d again. Okay, and then we could also specify the value of our y. Okay, so we could, build and run our application, and of course, we will get this particular output. So the value of x from initial value of our x is 5, right? So it will try to run 5 times, and then it will try to display 1, 2, and 1, 2, 3, 4, and 5 for our value of our y. Okay, and then of course we have the 4, and then we also have 3, and then we also have 1 and 2 and 1. So you could do that, guys. As I've said, you can do nested for loops or nested loops in your C program. So you could increment, you could use decrement inside your loops. Okay, so, and guys, if you want to practice more about using loops, you could, try to print different patterns. If, for example, you want to print a rectangle or triangle, you could display inverted triangle by using the asterisk symbol. So you could do that by using your loops. And in this video, guys, we're going to discuss how we can use switch multiple selection statement inside our C program. So from the previous tutorials, guys, we have learned how to use if. We also have learned how to use if else, and of course how to use the nested if else statement inside our C program. Now occasionally there will be an algorithm that will contain a series of decisions in which a variable or expression is tested separately, and the output or the statement or the actions that could be taken depends on the series of decisions. This is what we call multiple selection, and C provides the switch multiple selection statement to handle such decision making. So now let's try to look at the basic syntax of switch statement. So the switch statement, guys, starts with the keyword switch, and then open close parenthesis and open close curly braces. And inside this open close parenthesis is the variable. So variable of interest. So the output, guys, or the statements that are executed depends on the value of this particular variable here. So we have here switch statement or switch keyword, and then open close parenthesis, and then the variable or expression, and then of course open close parenthesis. And inside this open close parenthesis, guys, are the case label. Okay, so for example, you want to check for the value of 1, and then it should be followed by the break keyword, which means that it signifies the end of this particular case 1. Okay, and then you could add several case label here. So for example, case 2, and then you could add the break statement. You could also add another case label 3, and then the break statement, and of course you need to add the default case. So the default case, guys, will serve or will be executed if there's no case label that satisfies the value of our variable or expression. So for example, we have here 1, 2, and 3, and the input is 4, so it's gonna execute the default value or the default statement, default case. Now you could, inside this particular case, we could execute some statements. So for example, you have chosen case 1, so we could end this with a semicolon. So we could do the same for the other cases. So like this. So in this particular case, you have chosen case 2 and you have chosen 3. And the default is you have not chosen
from the values 1 and 2 and 3. So 1, 2, you have not chosen a value in 1, 2, 3. Okay, so we could try this, guys, and of course we need to add a variable here. So input, and then we could, scanf or ask the input from the user. So %d, and then the variable input, ampersand, and then input. Okay, and then, guys, we could print, please choose a number 1, 2, or 3. Okay, so let's try this. Okay, so let's try to build and run our application. So we have to update this. So variable of interest is, of course, the input. Okay, so let's replace this with the input, and then build and run our application. So as you can see, it's going to run, and we need to input a number here. So please choose a number between 1, 2, and 3. So for example, we choose, or we input 1. So you have chosen case 1. Okay, and then let's try another one. So for example, 3. So you have chosen case 3. So basically, guys, it executed the statement under this particular case label. Okay, and so for example, you have inputted, or you have selected number 4 instead of the values 1, 2, and 3. So it's going to execute the statement under the default case. Okay, so you have not chosen a value in 1, 2, and this is should be 3. And we could also use letters and characters inside our switch case statement. And basically here in our example, we're using the int type as the data type for our variable of interest input. And then we're setting the case labels into int1, and then int2, and then int3, and then we're executing statement based on the value of our input. Okay, but as I've said, we could use characters or letters. And so for example, you want your user to input letter A, you want your user to input letter B, and then you could execute statement based on that particular letter. So for now, let's try to implement this inside our program. We want our user to input letters A, B, or C, and then we could, output different statements based on that particular character. So now we could display, instead of please choose a number, we could, say here, enter a letter. You could select A, B, or C, and then based on this particular letter, we could output or execute commands or execute statement. Okay, and then we're going to use the method get char. Okay, so this will return the int equivalent of the letter or the character that the user has inputted. Okay, and then we could try this inside our switch statement. So instead of using case 1, we could say here case A, and then here we could use case B, and of course here we could choose or set the case C. So every time the user types in the A, so it should print you have chosen option A. So we could copy and paste this. So B, and then of course, you have chosen option C. And in our default, wrong option. Okay, so we could try this. Let's try to run or build and run our program. So enter a letter A. For example, we type in A. So you have chosen option A. So let's try this once again. So for example, the letter that has been, or the user inputted is B. You have chosen B. Let's try this once again. So for example, the user types in D, and then it will display wrong option. Okay, and then of course guys, you can make it this way also. So for example, you want to add also the lowercase of letter A. So case and then the lowercase version of A. So you could do it like this. So you have case A and then case with the lowercase a, and then you could also do the same with the B, and then you could add the lowercase b here, and of course you could also do the same for your C. So lowercase c, lowercase b, lowercase a. So it's going to, execute based on this. It doesn't matter if it is uppercase a or lowercase a. So let's try this once again. So for example, we want B. So you have chosen option B. Okay. So let's try this another time. And then C, lowercase c. So you have chosen option C. Okay. So I think it is clear to you how to use the switch case statement in C programming. And in this video guys, we're going to discuss, and I'm going to teach you how to implement functions in our C program. So basically guys, a C function is a self-contained block of statements that can be executed repeatedly whenever we need it. So if you think about it, it is just, a group of statements that we could call and we could use repeatedly within our C program. So in this particular video guys, we're going to discuss the benefits of using the functions in C program. We will also discuss the two types of functions in C, also the parts of function, the function prototype, the function definition, and of course we're going to discuss also how to call a function inside our C program. And lastly, we will implement a basic program to illustrate the addition of two numbers using user-defined function. So if you're excited guys, please make sure to watch the full video. You will learn more in this particular video tutorial. And by the way guys, if you are new here in our YouTube channel and you like content about programming, so go ahead, make sure to subscribe and press the notification bell so you'll get updated whenever we have a new upload regarding different programmings or different topics. So we have topics Python, Java, JavaFX, C programming, and many other topics regarding programming. So now let's try to talk about the benefits of using function in C. So there are a lot of functions that we could associate in using function inside our C program. So the first one is modularity. So when we are using functions, it could provide modularity in our code. So it means that we could define different functions. We could readily call our functions, and we could call this particular function if we need it or we need to execute certain statements. And of course guys, the function also provides reusable code, meaning it will save us a lot of space, and it could be, our code could be more readable by using this particular function feature.
So that's readable or usable code. And then in large programs, debugging and editing tasks is easy with the use of functions. So functions make it easy for us to implement our programs. So the program can be modularized into smaller parts. That's what I have said earlier, that we could, develop a certain module inside our C program, and then we could call that particular module or statements or group of statements if we need in a particular situation. And the next one is separate function independently can be developed according to the need. So for example, guys, we could group our statements depending on the need, or depending on the function or the purpose of that statement. So we could group that statements and place it inside our C function. So actually, guys, there are two types of functions in C. So the first one is, let me type it here, type of functions. We have the first one, built-in function. Okay, so built-in function, of course the system provided these functions and stored in the library, therefore it is called library functions. So we are using scanf, printf, strc, py, strlwr, strcmp, strlen, strcat, and many more functions that are already available for us whenever we try to run a program. So from the previous tutorials, we have used the printf. So as you can see, this particular function, we did not implement this. The system provided it for us, the printf, and this particular function will let us display certain objects or statements that we want to display inside our C program. So to use these functions, you just need to include the appropriate C header file. So that's why we have here the include statement at the top of our program. So basically, we're including all the necessary function that we could use inside our C program. And of course, guys, the second type of method is what we call the user-defined functions. User-defined functions. Okay, so user-defined functions. These are the functions that are defined by the user at the time of writing the program. So that's basically us, or the programmer, that define the functions. Okay, and then of course the same with the built-in function. We could readily use this particular functions inside our C program. Now there are also parts of our function in C programming language. We have the function declaration. We also have the definition, and we also have the function call. So this is basically the actual flow of the function. We have the function declaration, and then we have the definition. We have, of course, the function call if you want to use that particular function. So we have here, for example, syntax for function declaration. So we could this will be the function declaration. This is just an example, guys, on how you could declare a certain function. So the syntax for that is data type, and then function name, and then of course open and close parentheses, and then in here we can specify the parameter list, okay, or the variables that we want to use inside this particular function. So our example of that is like this: int, which is the data type, and of course addition, which is the
name of our function. So addition, and then the return type is int, and then of course the list of parameters, and in this case we don't have any parameter in this particular function addition. So we also have the function definition. This is actually what the actual function would look like. So this will be function declaration, or I mean function definition. Okay, so we could the basic syntax to this is return type, and then the function name, and then function arguments, and then curly braces. So it should include the close or open and close curly braces. And then inside here is the body of the function, or simply the statements that we want to execute inside this particular function. So whenever we want to call this function, this will be the statements that would be executed inside this particular function. So in order for us to call a function inside our C program, we just need to specify the method name, and of course we need to supply parameters if there are any, and we would also need to specify the return type of our function. So now let's try to implement a simple program that that could illustrate the addition of two numbers using user-defined function. So we have here the main function, right? And then in here, after the main, or after the closing curly brace of our main function, we could create our own function right here. Let me close this first so you can see better. So we could add a function here returning the total of two numbers. Okay, so we could declare it like this: int, and then addition, open and close parentheses, and then open and close curly braces. And of course, guys, as I've said, this will be the body of our function. So in here we could define local variables. Okay, so local variables. So for example, we have int num1 equals 10, and then num2 equals 5. Okay, so these are local variables, meaning these are the variables that are declared and defined inside the addition method or function. Okay, so we could say here return, and then num1 plus num2. Okay, so that's the statement that we want to execute whenever we try to call the addition method, or I mean function. So inside our main function, we could call this method addition. So we could declare a variable here, int answer, and then we could say answer equals, and then the addition. So basically, whatever the return value of this addition method, it will be assigned into our answer variable. And of course, we could print or display this particular value. So we could say the total of two numbers is, and then the format specifier, which is %d, and then the answer, which is the answer variable. Okay, so we could build and run our application, and then we have here the output. The total of two numbers is 15. Okay, so that's how the function works. And as you can see here, we have defined our function with the statements inside our C function to return the total of the number 1 and number 2. And then inside our main function, we have declared the answer, and then the type is int, of course, because the int is should correspond to the return type of this particular function. And then answer equals the addition. And then the last thing that we did here is to display the total of two numbers. And in this case, 10 and 5, which makes it, the value or the output is 15.
And in this video, guys, we're going to learn how to use C function arguments or parameters inside our function. So from the previous tutorial, we have learned how to define and declare our function inside our C program. And of course, we have learned how to use the basic syntax to create a function and implemented a simple function that could add two numbers. Okay? So as I've said, guys, in this video, we're going to focus on the function arguments or function parameters. So while calling a function, the arguments can be passed to a function in two ways. So there are two ways on how we could pass the parameters or the arguments into the function. So the first one will be call by value, and the second one is call by reference. Okay, so in call by value way, the actual parameter is passed to a function, and then new memory area created for that particular passed parameters, and then it can be used only within that function. And the actual parameters cannot be modified in the call by value way of passing the argument into our function. While call by reference, so instead of copying a variable, an address is passed to a function as parameter, and then we could use the address operator, which is the ampersand symbol. I know you're already familiar with this. So address operator is used in the parameter of the called function, and of course the changes in the function reflect the change of the original values. So we could understand this better if we try to implement our function by creating a simple project or simple application that could demonstrate the call by value or call by reference. So first, let's try to create a program that would pass the argument as, or it could call by value. So the first thing that we're going to need is, of course, to it's actually the same with the program, or I mean function that we have created from the previous tutorial, but the difference is that in this particular video we're going to use parameter or argument. So the first variable that we're going to declare here is the answer. So the type is int, and then we have the variable name num1, so the value is 5, and then int num2, and then the value is 10. Okay, and of course, guys, we could declare the function. So for example, we could create the function right after this closing curly brace of our main function. So the first thing, of course, is the return type, and in this case int, and then the name of our function, which is addition, and we could say here int a and int b. Basically, it means that this particular function could accept two parameter, int b and int a. Okay, and then in here we could return the value or the total value of these two parameters, so a plus b. Okay, and of course, guys, we could declare the function right here. So we could add the function declaration here, function declaration. So you could say here int addition, and then this particular function is gonna take two parameters, int num1 and int num2. So as you can see here, guys, this is only the function declaration, okay, and this is the function definition.
function definition. Again, this is function declaration, and function definition. So now we could try to call our function by value. So for example, we could say here answer and then equals addition, which is the method or the function that we have created here. And then we could pass along the values of num1 and num2. Okay, so let me explain this first for you so it would be clearer for you. So we have here the parameter num1, num2. As I've said, in call by value, the actual parameters cannot be modified because num1 and num2 it won't change even if we change the parameters here, the int a and b. So the value of num1 and num2 would not change even if we try to modify this int a and b inside our addition function. So the actual parameter is passed to a function, and then new memory will be created for our parameters int a and int b. Okay, and of course we could display here the result. So printf, and then of course the statement, the addition, or we could say the total of two numbers is, and then the format specifier %d, and then the variable answer. Okay, and then we could clean and build our application, or build and run, and it should display the output something like this. The total of two numbers is 15. Okay, so you get the point. This is the calling of function by value. Okay, now if we want to try to call a function by reference, as I've said, we're going to use the ampersand symbol. So ampersand symbol, or it is the address operator, and we're going to use that in our parameter of the called function. So let's try to implement a function that could call by reference, and you should see by now how the call by reference and call by value is different. So the same thing, we're going to declare the method here. The return type is int, and then the name is addition, and then it's going to take two parameters with type int. Okay, and then we could also use this int answer, and then the same value, for example. And now guys, instead of just using this num1 and num2, we could add the address operator, the ampersand symbol, or the address operator in C programming. So basically guys, we're sending, or we're passing the address of this particular variable into our function. So whenever we change this value inside our function, it's going to reflect the value of our num1 and num2. Okay, so we have here the ampersand or address operator, and then we call the function right here, and then display the answer. And of course we need to add the asterisk symbol for this variable here, or the argument, and then one for the other variable b. So this means that it is the operator that is used as a pointer to a variable. So it's going to point the address to that particular value of num1 or num2. So of course we need to add this also here, and of course for our variable num2. Okay, and then as I've said, if we want to change the value of num2 here inside our function, we could do that, and it's going to reflect the changes of this num2 and num1 variable. Okay, and then of course we could still use the asterisk symbol here, and let's try to run our program for now. So build and run, and it's going to answer, or it's going to the output this way. The total of two numbers is 15. Okay, so let's try to modify the num1 and num2. Okay, for example, inside this particular function, we're going to change the value of our variable a. So instead of 5, it's going to like maybe 6. Okay, so we could do that by using this particular um, variable argument. We could add here the um, variable a, and then we could say 6, then semicolon at the end, and we could try to display the value of our a. So the value of a, and then %d, and it should, the variable a correspond to the variable num1, right? So we could copy and paste this. So notice that num1 equals to 5 here. Okay, so let's see what's the output of this. So build and run our program. So as you can see, we have here the output. The total of two numbers is 16, and the value of a is 6. But as you can see here, a corresponds to the num1, right? Num1. So we have here num1 equals to 5. And then we change the value of num1 by using the reference of variable a, and then we set it to 6. That's why we're getting 6 here, and then the total of our addition is 6. Okay, so and in this video guys, we're gonna learn how to use arrays inside our C program. So basically guys, we can declare variables to hold single element or single value inside our C program. So for example, like this, age or int age, and then we could assign it to a value 5, for example, like this. So this particular variable will hold the value 5, or a single value 5, and then it's going to assign to the variable age. Now, what if we want to store like 50 series of values? Like there are 50 age that we want to save. For example, there are like 50 persons that we want to save the ages. Then this particular declaration and statement will not suffice, because we're going to like declare it one by one. So for example, int age 2, and then 6, and then int age 3 equals 7, and int age 4 was like 10, and so on. So basically guys, this is not a good programming practice to declare multiple variables, or multiple variables to hold a single set or single type of data. So that's why we need the capability of an array. So basically guys, the array is a data structure in C programming which can store a fixed size sequential collection of elements of the same data type. So in this case, guys, we're just, collecting and saving the same data type of data, which is int. Now, what we can do here is we can define an array, and then we could set the length. Say, for example, we want to save 50 ages, right? And then we could save the age into that particular array. So let me show you an example. So this is how you can create an array inside your C program. So basically the first thing is you have to specify the type of your data that you want to save in that particular array, and then the array name. So basically this is just like the variable name. So you have to label your container, and then of course you have to specify the type of data that you want to save in this particular array. And then you have to add the square brackets, and this signifies that this particular variable is an array. And then inside this particular square bracket, you can declare the size, or specify the size or how many values that this particular variable could hold. Okay, so in a typical C program, you could do it like this. So for example, the type is int, right? And then you could say ages or age, right? So this is the array name, and then this square brackets, and then you have to specify the size. So for example, 5. So you want to collect 5 values or 5 age of 5 persons. Okay. So again, this is the type int. You have to specify the type, and then you have to specify the array name, the variable name, and then of course square brackets, and then the size of your array, or basically the amount of values that this particular array could hold. So after this, you could say equals, and then you could specify the array or the elements of your array. So for example, we could take all these values 5, 6, 7, and 10. So 5, 6, 7, and 10. And so for example, because our array contains or should contain 5 elements, you could add another one here, for example, 8 or something. Okay, so again, this is how you can create an array of values. So int is the data type, and then of course we have the array name, and then square brackets with the size 5. For example, your array should be 5, and then equals, and then the curly braces, open and close curly braces, and then the actual element value. For example, in this particular statement, we have 5, 6, 7, 10, and 8. So that's how you can initialize an array in C program. Now, you can access this particular or this elements or these values by using what we call index. So in C programming or any other programming with arrays, you could access the values by using index. So this index is based. Zero based. It means that it will start with 0. Okay, so meaning if you want to access the value 5, so you have to use 0 index. Okay, this will be 0, and then this will be 1, this will be 2, this will be 3, and this will be 4. So again, if you want to access or get the value of this particular element, you have to use the 0 value of your index, and then 1 for the 6, 2 for 7, 3 for 10, and 4 for 8. So let me show you how that works. So for example, you want to display the value 6. Okay, so all you have to do is use the printf statement, and then double quotes, and then %d, the format specifier for our integer values, and then comma, of course, and then we could use the name of our uh, what do you call this, array, so ages, and then we could specify the square bracket, and then the index of the element that we want to use. So for example, 6. So we want to use the index 1 for that to be able to get the value of 6. So let's try this. Build and run our program. So as you can see, the output is 6. As you can see here, 6. Right? Now, if you want to get the value 10, you have to use the index 3 for that, because as I've said,
the value is equivalent to the index 3 of our particular array. So build and run our program, and it should output the value 10, which sits on the index 3 of our array. So that's how you can access the value from our array. Now, so for example, you want to change the value of this array, right? So we have here 5, 6, 7, 8, or 5, 6, 7, 10, and 8. And then if you want to change the value of, so for example, this one, 5, the first element, all you have to do is specify the index also. So address, and then the index is 0. So then equals the value, for example, 11, semicolon, that signifies all of this long. So ages, so for example, we want to display this, what will be the value of our index 0. So we could test that by using the printf statement, and then instead of 3, you could specify the value 0 or index 0 here. So let's try this, build and run. And as you can see here, instead of 5, the initial value of our index 0, it returns 11 because we assign it, or we modify it by using the element or index 0 equal to the 11, which is that's why we are getting the 11 value here. Now this is particularly useful, guys, or if you want to work with the array, one of the best structure or the best statement that you could use to iterate the array is by using the for loops or loops inside our C program. So we could say this here, for example, for, so we're gonna use the for loop statement here, and we could specify, for example, int index equals to 0. We want to start with 0 because, as I've said, the index of our array is 0 base. It will start with the 0 number. Okay, so index equals 0, and then semicolon, and we're going to say here index less than the actual value of our array, or I mean size of our array. So 5, less than 5. So another semicolon, and then index plus plus. Okay. And inside the for loop, we could display the element of our array. So we could use this printf statement, and then we could use the index variable here, and then change this. We could say index equals %d, the format specifier, and then we could say equal to %d, and then of course the actual value of our array index. So in here we could specify the index. Okay, so it should display the index, current index, and then it should display the actual value of that particular index. So we could build and run our program. Let me add first the \n or new line state sequence, new line, and then it should display this particular output. So at index 0, we have the value 11. At index 1, we have the value 6, right? Index 0 is 11 because we already modified our array, specifying the array or index 0 should be equal to 11. And then at index 1 equal to 6, right here. Index 2 should be equal to 7. Index 3 is 10. Index 4 is 8. Okay, so that's how easy for us to access and change the value of our array, and that's how we can define our single dimension or one dimension array inside our C program.
And in this video, guys, we're going to talk about multidimensional arrays in our C program. So from the previous tutorial, we have learned how to use the basic array. So we have implemented one-dimensional array. We trying to display the contents of an array by using the for loop. And of course, we declare and initialize one-dimensional array from the previous tutorial. Now, as I've said, from this tutorial, we're going to learn how to work with multi-dimensional array. So basically, guys, multi-dimensional array works like the same with the one-dimensional array, but the difference is that it contains the array contains a set of arrays. So in C programming language, it will allow us, or it allows us to use multidimensional arrays, and the declaration or multidimensional declaration for that is by using the type, of course. As I've said from the previous tutorial, if you want to store multiple values, you have to use arrays, and in order for you to declare an array, you have to specify the type of that particular array. So you have to specify the type, and then of course the name of the array, and then you have to specify the size here. So for example, size. Now this is good for one-dimensional array. So you have to specify the type, the name, and of course the size of your array. Now comes the multi-dimensional array or two-dimensional array. So you could do it like this. So size 2, and then this is the size 1. So this is how you declare multi-dimensional array or two-dimensional array inside our C program. So the type, of course, you don't want to forget that the size of, or I mean, the type of the value that you want to save in this particular array. So, and then the name, and then of course the size 1, and then the size 2. Now, if you want to create three-dimensional array, you could do it like this. Size 2, I mean size 3. So you have square brackets for your size 1, square brackets for your size 2, and square brackets for your size 3. So again, this is how you can declare your multi-dimensional array. But the simplest form of multi-dimensional array is by just specifying two sizes, and basically, guys, this will represent the columns and rows of your array or multi-dimensional array, because multi-dimensional array works like a table. So size 1 will be your um, number of rows, and the size 2 will represent the number of columns. So let's try this. Let's try to declare and initialize multi-dimensional array. So following this particular declaration type. So the first thing is of course the type. So int, and then we could say here a, or a variable name a. This is the name of our array, multi-dimensional array. And then of course we could specify the size for our rows. So for example 3 right there, and then the size of our columns or number of columns. So that's basically like 4, and then you could initialize this by using the equal sign and then open and close curly braces. So in this inside these curly braces, we could declare or initialize the values for our rows and columns. As I've said, multidimensional arrays are composed of arrays right there. Okay, so we could add array of values right here. This will represent the row 1 of our array. So like for example 0, 1, and then 2, and then 3. Okay, so again, this is for initializing the row initializing the row index by 0. Okay, so we could access this by using the index 0. Okay, and for example, basically we declare it here like 3, so we need to add more arrays to this. So open and close curly braces and another one to make it, the length is 3. So in here we could display or add 4 and then 5 and then 6 and then 7. Okay, and then the other row will have 8, then 9, and then 10, and then 11. Okay, so basically we now have declared and initialized our multi-dimensional array. So the three here represent this rows, 3 rows, and as you can see here we have declared 4 columns. So it should count, or I mean, the columns start from this 0, 4, 8, and then 1, 5, 9, 2, 6, 10, 3, 7, 11. So this will, the 4, the 8, and the 0 represents the column 0. And then 1, 5, and 9 represents column 1. So why this is representing column 0? That's because our index is, um, is 0 base, or meaning it will start counting from 0. So this will be the column 0, the column 1, the column 2, and the column 3. Okay, and of course, um, we could try to display the value of this. We could access the values of our multi-dimensional arrays by using the indexes of the columns and rows. So for example, we want to change the value of um, the values that we could get from the row 2 and um, column 3. So basically the value of, or the value that we could get from our array index 2 and 3 is 11, because this is the row 2 and this is column 3. So 0, 1, 2, 3. So we get the 11, or the value 11. So if we want to change this to something like 8, so we could do it or assign a value to this by 8. So it should display 11, or I mean 8 instead of 11. So we could try that. So printf and then percent %d, which is the format specifier for our int value. So we could specify the array index 2 and then index 3. So if we try to compile and run our program, we should get now the value 8. Value 8, as you can see here. That's because we already modified the value inside the array of index 2 and 3. So let's try to comment this and then compile and build our program. And as you can see, we're getting 11. That's because that's the initial value of the array index 2 and 3. Now we could use array, or I mean, we could use loops here to access and change the value of our array or multidimensional array. And of course, because we're using multidimensional array, we could also use nested loops to change and access the values of our array. So, for example, we could declare for loop here, and this is, for example, int and then row equals 0, and then our row is less than, or yeah, row is less than, um, like for example, 2 or 3, okay, and then row plus plus. So basically, we're iterating from 0, 1, and 2 because we only have like 3 rows, but we're starting from 0, so that's making it like the value of our row should only be within 2, not 3. That's why we're using single, or I mean um, less than 3 right here. And then of course we could make another loop for our column. So int column and then equals to 0, and then um, column is less than 4, and then um, we're going to say here column plus plus, okay. And then of course we could use this particular printf statement to display the values of our array. So percent %d, we could use here the array name, which is a, because we're using the array name a. So a, and then um, we are going to specify here the columns and rows. So percent %d, and then here percent %d equals percent %d. So inside here we could specify the row and then the column, and of course the value of that particular row and column. Okay, so this will be row, and of course this will be column. Okay, so again, we're just trying to get the value of inside our array represented by this particular row and column. Okay, so these are the indexes, the row and column. So let's try to build or compile and run our program, and we're getting this particular output right here, but we don't want that. Let's try to add a backslash n to add a new line every execution. So as you can see here, we have all the values coming from our array. So array, and then we have index 0, 0, so the value is 0 right there, as you can see. And then a0, 1, so the value is 1. a02 is 2. a03 is 3. And a10 is 4, and so on. So that's how you can use the multidimensional array inside our C program. Okay, and I think that's clear enough how you could iterate and modify your multidimensional array by using for loops.
And in this video, guys, we're going to learn how to use array as a function parameter. So from the previous tutorials, we already implemented functions that could take few parameters and then return a value based on the parameter that we have passed to the function. Now, in this particular video, guys, we're going to learn how to pass the array as a function parameter. And of course, we already know how the array works inside our C program. We already implemented a simple program that demonstrates the capability of using array. We already implemented a multi-dimensional array and even iterated the content or the elements of our array. Now, we could take that further by using a function. And in this video, guys, I'm going to show you how you can sum up the values of your array. And then we're going to use a function for that. So as I've said, we're going to pass the array as a function parameter. So here inside our C program, we could declare a new variable or a new array. So for example, int and then my number array. Okay, so my number array is the name of our array, and then it should take in or has the size of
say for example 6. So the number of elements is 6, right? We could specify the values inside our curly braces. Now we could um, specify the values 23, 30, 21, 18, um, let's say 17, 1, 2, 3, 4, 5, and another one for our last element, say for example 25. So these are all the elements of our array, and then we're going to sum up the value of this by using a function. So what we can do here is to add a function above the main function or whatever. We could also insert function right after the main function. So for example, the function will return the total, so it should say int. This is the return type, and then the name of our array, so total value of array. So this will be the name of our function, total value of array. So again, this is the return type, and this will represent the total value of the elements that we have here. So total value of array, and then of course we need to specify the argument or the parameters, and because we're trying to sum up the value of our array, we could specify that the first parameter is an array. Okay, so for example int and then number array, and this is the first parameter and represents the my number array here. Okay, and then we could also specify the size of the array. So basically we have 6 here, so we could say here int and then size, and again this will represent the size of our my number array. And of course we need to add curly braces inside, and inside this function we could add the logic to add all the elements of our array and then return the sum or the total. So we could say here int total equals 0. Okay, that's the initial value of our total variable, and then we could um, try to iterate the elements of our array by using the for loop statement, the same for loop that we have implemented from the previous tutorials. Okay, so for loop, so we could say here int I equals to 0, and then I is less than the size of our array, and then I plus plus, and then inside the for loop we could say sum or total equals total plus the number array right there, and then we could specify the index, which is we're gonna use I. So this is the variable I that we have declared inside our for loop. So number array and then the index I. Okay, and of course guys, this is the same with this particular line. We could write it with this particular line, total equals our plus equals and then number array, and then of course specify the index of that particular number array. So again, this particular line is the same with this line. All we are doing here is trying to accumulate the total of our number array right here. So after the total plus equals number array, we could return the value of the total, so by using the return statement and then of course the variable total. Okay, so I think our function our function total value of array is already set. We could now call this particular function inside our main function right here. So basically, for us to call that particular function, all we have to do is use the name, which is total value of array. So total value of array right there, and then open and close, and then we're going to supply the parameters, which is the first one is the array or the my number of my number array. So my number array, and then of course the second parameter is the size of the um, array, which is 6 right there. And then of course this particular function returns int, which is the total. We could catch the value by using also int, and then you could say here sum equals the return of this function that has the parameters array and the size of the array. And then right after that one, we could print the sum of all the elements. So printf, and then we could say here the total value is, you could use the %d, and then \n, and then comma, and then of course specifying the sum variable. Okay, and now we could compile and run our program. So I think we have an error here because we use the comma, so we need to remove that and compile and run again our program. So it should say here the total value is 134, which is the total of this particular value elements here from our my number array. Okay, so we could also add function, or I mean add element to this particular array. So it should say after 25 we could add, like for example 50, and then another one 25. So basically the length of our array, or the size of our array, should be 8 because we already added two elements, the 50 and 25. And of course we need also to change this particular parameter here. It should say also 8. Okay, so let's try to compile and run our program, and as you can see here, the value is now 205. Okay, so let me explain to you in details how this works. So first, we define the elements of our my number array, and the size of this, or the number of elements of this particular array, is 8 right there. And then right after that, we call the function total value of array, and then we pass in the my number array as the parameter, and of course the second parameter is 8, which is the size of our number array. Now for the total value of array function, as you can see here, it takes two parameters, the array and of course the size of the array. And then inside here, we initialize and declare the total variable equal to 0, and then we iterate the my number array or number array by using the for loop, and then we use the I as the index variable, so I equals to 0, and then I is less than to the size that we have specified, and then I plus plus, and then of course in order to get the total of the elements, we're using total equals total plus number array. So basically this is the same with this line, total plus equals number array, and then specify the I index. So for example, this particular I, the value of I is 0, then it's going to get the value 23, and then I value 1, it should get the 30, I value 2 is 21, I value 3 is 18, and so on. So you get the idea. And then of course after that we get the total value, and then of course return that to this particular variable sum. And the last thing is we display that the total value is, and then specifying the sum of all the elements that we have from this number array. Okay, in this video guys, we're going to discuss what is pointers and how we can use pointers inside our C program. Okay, so if you're excited guys, please make sure to watch the full video. We're gonna be learning a lot in this particular video and in the succeeding videos about pointers. So basically, pointers in C are easy and fun to learn. So there are some C programming tasks that are performed more easily with pointers, and there are other also tasks such as dynamic memory allocation cannot be performed without using pointers. So it becomes necessary to learn pointers to become a perfect C programmer. So if you want to be like almost perfect C programmer, so it is necessary for us to learn pointers. Okay, and let's start learning them in simple and easy steps. So as you know, every variable is a memory location, and every memory location has its own address defined, which can be accessed using the ampersand symbol. So I think we already used this particular symbol before in our previous tutorials, but we're going to, tackle deeper what is this particular symbol and how we can use this in, working with pointers. And it is, denoting an address in memory, meaning the ampersand. And for example, we're going to define here or create a program that could showcase the capability of this operator and the basic access to or basic access to the pointer address. So for example, we have a variable int var1, and then we have char var2, which is the length, for example, is 10. So basically guys, as I've said, these variables has location or has a specific location in our memory, and every memory location has its own address. So in order for us to verify that, we could try to print the address or memory address of these variables. So we're going to use printf function, and then in here we're going to say address of var1 is percent %x. So this is the format specifier when we're trying to display the address of the variable. So %x, and then we're going to specify a new line here, and then comma, and then of course we need to use the ampersand symbol, and of course the name of our variables, if for example the var1. So the address of var1 colon and then %x, the format specifier, and then of course specifying ampersand and the name of our variable 1. And we could do also the same for the second one or second variable var2. So %x, and then this will be var2. So this is basically guys trying to test if this particular variables has, we will just display the address of this variable. Okay, so before we run our program, let's change first this, because I have forgot to type number 1, because this is supposing that this particular variable has the length of 10. Okay, so that's char var2, and then open and close square brackets, and then 10. Okay, so let's try to build and run our program, and as you can see, it's going to display the address of var1 is 61 fe1c, and the second one will be fe12. So that's basically the address of the variables var1 and the var2. So a pointer variable is a variable whose value is the address of another variable. Okay, so for example, direct access of the memory location. Now, like any variable or constant, you must declare a pointer before using it to store a variable address. So the typical, or the general form of pointer variable declaration is just like this. We need to specify the type, and then the asterisk or star symbol, or asterisk in other terms, and then of course the variable name. So that's how to declare a pointer variable. So again, we need to specify the type, and then asterisk symbol, and then the variable name. So here, the type is the pointer's base type, okay? And it must be a valid C data type, and of course, the variable name, or the var name, is the name of the pointer variable. And as you can see, guys, this particular symbol, asterisk symbol, is sometimes used to declare or used for multiplication process or multiplication operation, right? But in this particular case, it is being used as to declare a pointer variable. Okay. Now, in order for us to declare um, pointer variable based on this particular declaration form, so we could say something like int, and then percent, or I mean the asterisk symbol, and then the name of our variable. So this will be um, pointer pointer to an integer. Okay, and then we have, for example, double, and then the asterisk symbol dp, and this is basically the pointer to a double. We also have like float, and then fp. This will be obviously pointer to a float, and another thing, ch, and then this will be pointer obviously to a character. So the actual data type of the value of all pointers is, a long hexadecimal number that represents the memory address. So whether we declare it as int, we declare it as double, we declare it as float or character, so it's going to return a long hexadecimal number that represents the memory address. Now, the only difference between pointers of different data type or data types is the data type of the variable or constant that a pointer points to. So, for example, this particular variable points to this variable 1, then it's going to be a bit different because we are referencing to an int variable. So let me show you that how you can use pointers. We could remove this lines. Okay, int var1, we could assign a value to this like 20, and then this will be the actual variable declaration. So this particular variable has the value 20, and then we could declare a pointer variable. So int, and then asterisk ip. So this is pointer variable declaration. So you get to see the difference between this declaration. The pointer variable uses the symbol asterisk, okay? And then, of course, in order for us to store the address of the variable 1 into the pointer variable IP, we could use IP variable equals the ampersand symbol, and of course the var. Okay, so basically, guys, we're just passing the memory address of this particular variable 1 into the pointer variable IP. Okay, so for example, we could print the address of our var1. So printf address of var1. We could use percent x as the format specifier, and then \n for new line, and then um, use the ampersand symbol and then var1. So let's try to declare, or I mean display first the address of the var1, and then we could also do the same, print the address or the value of the pointer variable IP. So the value of IP, and then percent x \n, and then the variable IP. So let's try this, clean and build our program, and it should, display the same hexadecimal value. So address of var1 is 61FE14, and then the value of IP is, 61FE14. So basically, we're just trying to display, or I mean store the memory address of var1 into the pointer variable IP. Okay, and of course, if you want to access the value using a pointer, we could try to modify our program to access the value using the pointer variable. So printf, and then value of pointer variable IP. So for example, percent d \n, and then asterisk IP. So basically, we're just trying to access the value of this particular pointer variable. So let's try this, clean and build our program. And as you can see here, we have the address of var1 61FE14, and the value of the pointer variable, or I mean the address of IP, or the pointer variable IP 61FE14. And also here we could say that the value of this is 20, which is also the same with our variable 1. So that's how easy for us to use the pointers inside our C program. In this video, guys, we're going to be discussing what is strings in C and how we can take advantage of the usage of this particular strings. And then, of course, we're going to be dealing with the different functions that we could use in order to work with our strings in our C programming language. Now, if you are new here in our YouTube channel and you want content about programming, I am inviting you to subscribe and press the notification bell so you'll get updated whenever we have a new upload. So without further ado, let's dive right into our topic, which is the strings in C programming. So basically, guys, when we say string in C programming, it is the one-dimensional array of characters. This is called strings. In other terms, this is just a group of characters logically grouped together, and then there should be a sense why we're grouping these characters together, and this is terminated by null character \0. So actually, guys, there are two types of, or two ways to declare string in C programming. Okay, so we could declare it like this. Basically, guys, we have here the basic structure of our starter program. So hello world program. So I'm just going to delete that, and we're going to initialize or declare string in C programming. So you could do it like this. You could specify the type as char or car, and then of course the name of your variable. So you could name it something like this, name, and then you could specify here the um, length of your array of characters. So for example, 6, and then in here we could um, add the different characters for this particular string. So we could say here, for example, H, comma, and then we're going to specify another character. So first you have to specify single quote and then the character and then single quote to close that particular literal string, and then another comma and then single quote the character again, single quote, comma, and then single quote, another character. Okay, so you get the idea on how you could, declare your string variable in C programming. So I'm just going to continue working with this. So we have declared 6. So as I've said from the beginning, you have to, or the string, it is the one-dimensional array of characters and it should be terminated by a null character. So null character in C is \0. Okay, so basically now we do have the string name, and then we need to close this one up. So this is how we could declare our string in C programming language. And actually, guys, you could do it also like this. So for example, you don't need to specify the length. So char, and then you could say here last name, and then all you have to do is um, declare it as an array, but you don't have to specify the length here, for example 5 or 6 or something like that. So all you have to do is initialize this with an actual value, for example Hopkins, okay, something like this. Okay, and then close it with semicolon. So basically, guys, it means the same thing if we declare the string like this, or if you want to declare the string like this. And of course, we could try to display this. All we have to do is print and printf, and then we could say here the name is, and then we need to add the format specifiers. So %s for string, and then the new line specifier, and then comma, and then the actual value or string or the variable that we want to display, which is the name, something like this, and then semicolon. And we could also do the same for the last name. So printf, and then open and close parenthesis. The last name is again, %s, the format specifier for string, and then new line and comma, then the actual variable, which is last name. So we could try this, add the semicolon at the end of the line that denotes that this is the end of this particular line. Okay, so make sure you do that because the compiler would complain if you did not specify the end of a certain line. So now we could build and run our program, and it should display your string like this. The name is hello, as we have specified in our variable name, and then the last name is Hopkins, as you can see here. Okay, so that's a good start on how we could start working with our string in C programming language. Now, there are functions, as I've said, there are functions that we could use if we want to work with our string more. So for example, what if you want to copy a string, concatenate a string, get the length of the string? So we could do that we could also compare strings if you like to compare strings. So all we have to do, guys, we need to include a header file, which is string.h. So this header file contains all the functions that we need if we want to work with string in deeper sense. So string and then h. As I've said, this will contain all the functions that we need. Like for example, the str copy, str concatenate, str length, or if you want to get the length of a certain variable. So for now, let's just try this. This is for display the value of our string, right? And then of course, here we could use functions to our string. Okay, so perhaps the first function that we could use is the str copy. So the keyword for that is str and then cpy. So as you can see here, we have the auto suggestions, the str copy right here. So we could click on that, and then in here we could specify the string. So let me explain first what this means. So the strcopy function takes in two parameters. So the first one will be the destination, or the string that the copy of a value will be stored in, and then the second function, or I mean the second argument, will be the source of or I mean the source string. Okay, so again, it will take two parameter, this strcpy. The first parameter will be the destination string. The second parameter will be the source string. Okay, so for example, in this program, I'm going to declare another string here, and then you can say here str and then full name, for example. This is just for the sake of example. Okay, so for example, this will be maybe I don't know, maybe 13. Okay, so we don't set a value for this for now, and all we have to do is use our strcopy function, and then we need to specify the destination string. So for now, let's use this str full name as the destination string right there, and then comma, and then of course we need to specify the source string. Okay, and then the source string will be maybe the last name. Okay, now if we want to display the value of set or str full name, then we could use the printf statement, and then we could say here the full name is, and then %s again, \n for the new line, and comma for the actual value str full name right there, and then end this up with a semicolon. Okay, and then we could clean and build this just to see the result of our program. And in here we have an error. Okay, so we copied the actual value of our variable instead of using last name. So let's just modify this. So instead of Hopkins, it should be last name here. Okay, so clean and build our program, and it should be okay for now. And as you can see here, we have the display So the last name or the name is hello, as you can see, and then the last name is Hopkins, and the full name is Hopkins, and these two is identical. That's because we just copied the value of last name and assign the value to the str full name. Okay, so that's how easy for us to copy strings inside our C program. So there are other functions as well if you want to explore more about this. So for example, the other function that we could use is str say at or str cut. So this will concatenate the string or toString. So basically it will just takes two parameters, the first one and the second parameter, and then it should combine these two string to to form a new string. So let me show you that. So let's just use this str cat, and then maybe we'll just use the name and then the last name. So the first string will be name, okay, and comma, and then we need to specify also the what they call this, the string or the second string, which is the str full name, okay, and then semicolon, okay, and then after this we could display the value of our name. So all we have to do now is copy this and paste it this here, and let's clean and build our program. So first now let's just close this, close the output first, and then clean and build our program, and it should display here what we have done so far. So the name is hello, the last name is Hopkins, the full name is Hopkins, and as you can see here, the name is hello Hopkins. So as you can see, it concatenated the name and then the last name. So the name got the value of hello, and then the last name got the value of Hopkins. Okay, so I think that's all there is to it for this tutorial, and if you want to learn more about strings, all the functions, you could explore the documentation. So if you want to know more about the different functions available in um, this string.h header file, you could visit this website, and then you could see here the commonly used string functions. So we already have used the strcpy, strcat, and of course the other most commonly used string function is getting the length of your string. Okay, and in this video guys, we're gonna be learning structures in C. So we're going to explore what is structures and how we could use structures inside our C program. So basically guys, when we say structure, it is a user defined data type. It is used to store a collection of different kinds of data. So in a sense, it could be something similar to an array. So basically it is like a collection. The only difference is that an array is used to store the same data types. So in an array, if you want to save an integer value, so you have to make sure that all the elements of that particular array is also int or integer. And if you want to store double, so it should have double, or it should contain all double elements. While if you want to use structure, you could declare multiple data type inside this particular collection. So in order for us to use structure in C, we're gonna be using this particular keyword struct. Okay, so this is how we could create a structure in C programming. So struct. So variables inside the structure are called members of the structure. Okay, so now let's try to define a structure in C. So say for example, we want to um, try to declare a struct courses. So all we have to do is specify the keyword struct. Okay, and then this is going to make sense later on if we want to access the members of this particular struct. So for now, let's just stick to this. Struct is the keyword that we could use to declare or define a structure in C. So again, that's the keyword struct, and then we could specify the structure name. So this could be any name that you want. So for example, we could name this courses. Okay. So this particular courses, this will contain different variables. Okay. So as you can see here, we have added curly braces, opening and closing curly braces. And then at the end of the closing curly brace, the semicolon that signifies the end of this particular line. Okay, and then inside here, as I've said, we could have multiple variable type. Okay, so for example, number 1 will be char or car, and then we could name this, for example, website, and then the length is 50. Okay, and then semicolon, and another one, car or char, and then subject will be the length 50, and then the last one will be about price. Okay, so as you can see here, guys, we have the struct courses, and then it contains 3 different data types of variables. So we have here website with length 50, subject length 50, and then price, which is an int or of type int. Okay, that's how easy for us to define a structure in C. Now we could access the struct courses, but basically we need to move this outside of our main function. So we have to move this. I'll just have to cut and paste this. So it should be outside our main function, because we're going to declare, or access the struct from this main function right here. Okay, so you could think of this if you are into object-oriented programming, you could think of this as a class for now, but this is different because this is a structure, which is a collection of different variables or different data types. But you could think of this as an object or a class for now, and then we could access this inside our main function. So in order for us to access that, we just need to specify the name of our struct inside our main function. So all we have to do is use again the struct keyword like this, and then the name of the struct, which is courses. Okay, and then we could assign an alias to this. So for example, course, or maybe C, a big letter C. Okay, big letter C. Okay, and then semicolon. So that's how we could access this courses struct inside our main function. So all we have to do is use the struct keyword and then the name of our struct, which is courses, and then assign an alias to this struct. Okay, and then after that one, we could initialize perhaps our variables, okay, or members of this struct. So all we have to do is we could say here initialization. We could now access the members of the struct courses by using this alias. So initialization, for example, str copy. Okay, so I believe I have already showed you how you could assign a value to a string, because we're going to be assigning value to this website. So this is a string collection of um, characters. So strcpy, and then we're going to say here c, and then website. So as you can see here, we have the access to all the members of the courses struct. So we're going to use the website first, and then we're going to assign a value here. For example, www programming knowledge, something like that. So basically what we're doing here, .com, we're just doing here is we're just getting the website member and then assign a value to that, which is the www.programmingknowledge.com. And after this, we could, access this value by using this member of struct. So later on, we will try that. But for now, let's just move to the next member. So again, we're going to use strcopy, strcpy, and then now we're going to use the subject. So the subject will be introduction to C programming. So that will be the subject for this particular course. So again, we're just doing here, we're just getting the subject member of our struct and then assign a value to that, which is this string introduction to C programming. Okay, and of course the other one, or the last one, will be the price. So what we do here is use the C alias that, and then price, and then we could assign a value here. For example, we want to specify a value or a price here like $15 or something. And then after that, after initialization, of course, we can use these values right here. So all we have to do is we could say here print. So we could use printf statement, and then we could say here website percent semicolon r colon, and then percent s, and then we're going to add new line here, comma, and then the member of our struct. So c dot, and then website, okay, and then semicolon at the end. So we're going to do the same for the other members. So the next one is the subject. So percent s, and then \n, and then we're going to access the subject member of struct, and then the last one will be printf. I mean the price. So price, we're going to do the same here, percent d, that's the format specifier for our integer values. So c dot price, okay, and then semicolon at the end of this line to denote that this ends with this semicolon. Okay, so now let's try this. Let's build and run our program, and we're having an error here. Error expected, because that's because um, we did not add the semicolon here. Okay, rookie mistake. Build and run, and as you can see here, we now have the values displayed here in our console. So the website is www.programming.com, and then subject is Introduction to C Programming, and the price is $15. So that's how easy for us to use struct in C, and then we could, make this collection of different variables, and then we could assign values, initialize, and then we could also change if we want to change the values after initialization, and then after that we could display the values or the actual values of the members of our struct. And in this video, guys, we're gonna learn how to use unions inside our C program. So from the previous tutorial, we learned how to define and use structure, and then we also implemented different methods or different functions that we could use whenever we are working with structure, right? So at this point in time, we will be learning how to use union also. So basically, union and structure is almost the same, but there's a significant difference that we will discuss later on. So the thing about the thing about structure is that we can store different data types in different memory location. But when we say union, we can store different data types in the same memory location. So that being said, if we try to define union, a union is a special data type available in C that will allow us to store different data types in the same memory location. So you can define a union with many members, but only one member can contain a value at any given time. That's because we store the data inside the same memory location. So in other words, all the members of the union share the same memory location. That's why every time we set a value to a particular member of the union, other values will be erased and then replaced with the new value of a particular member. So to define a union, you must use the union statement. So from the previous tutorial, we used struct for the structure. But in the case of defining a union, we will define a union by using the union statement in the same way as you did while defining the structure. And the union statement defines a new data type with more than one member for your program. So basically, it looks like this, but instead of struct, you're gonna use union. Okay, so that's union, and then of course the name of your union, for example, data, right there, and then you have to add open and close curly braces. That signifies that all the variable inside these curly braces is a member of the union data. Okay, and then of course we can define the members here. So the same thing with our structure. So that being said, we can say here int I. Okay, and then we could also add float f, and then say for example char str, and basically for example the length for this is like 10. Okay, so let me show you first how this particular union works. So the union tag is optional actually, and each member definition is a normal variable definition, so such as I or int I or float f or any other valid variable definition. And at the end of the union's definition, before the final semicolon, you can specify one or more union variables, but it is optional. So you can also say here the name of your union is like data. Okay, so you can refer to this data, and then you can now you now have the access to the members of your union by using this reference. Okay, now a variable of data type can store integer, float, or string of characters. So it means a single variable and then same memory location can be used to store multiple types of data. So you can use any built-in or user-defined data types inside a union based on your requirement. So it depends on you. So the memory occupied by a union will be large enough to hold the largest member of the union. So for example, in this particular code, data type will occupy 10 bytes of memory space because this is the maximum space which can be occupied by a character string. Now, we can display the values of this union. So for example, we try to display all the, any value coming from this union. So at first we could, refer to the members by using this reference. So data dot, and then we could say here I, then we could initialize this value into, for example, 5, like that. And then we could print the value of I. So here we could say the value of I is, and then of course we need to have the format specifier for our I. Okay, so D, and then we could add also the new line, and then comma, and then of course data dot I. Okay, and then semicolon. So let's try to run our program. So basically, let's hope that we won't have problems. So build and run our program, and as you can see here, the value of I is 5. So we were able to set the value of our data I member and initialize it to 5. Now take a look at this. For example, we set the value of float into a something, into some value. For example, data that f equals to, for example, let's say 22 or maybe like 8. Okay, and then we could try to maybe add 8.5 here just to make sure that it is kind of like float value. So we set the value of our f into 8.5. So we could, build and run our application. And as you can see here, we're getting the value of I is something like this. Okay, so the value of I is something like this. That's because the value has been, corrupted when we try to set the member f into something like 8.5. And as you can probably remember that the members of the union share the same memory location. So that's why if we try to change the value of a certain member, then it will override the value of the other member. So that's why it's somehow corrupted our value of I here, and we're getting this random number like this. But the purpose of using union actually is to have some sort of a value at a certain point of time. So for example, if we want to make use of the union, we could try to display the value of I right here after the initialization. So the value of I is, and then we're getting the value of I member here, And then also if you want to, display the value of the float f value or member from this union, then what we could do here is change this into f. That's the formal specifier for a float value. And then we could say here we want to display the member f from the data union. So we could actually get the correct value right after this. So let's try to run this. So build and run our application, and as you can see here, we're getting the value of our I is 5. So let's change this. Instead of I, this is member F, and this is member I, because this is a member of this union. So let's build and run our application, and we're getting this output. The value of member I is equal to 5, and then the value of member F is equal to 8.5. So that's basically the correct value that we're getting, or we're setting here in our main function. Okay, so I think that's all there is to it for this tutorial. And as a sort of summary or review, we have learned how to use union inside our C program, and then we learn that we can store different data types in the same memory location by using this union keyword, and then store different variables with different data types. And yeah, we also set and initialize the value of the members of our union, and then also display the values individually right here in our C program. And in this video, guys, we're going to be discussing typedef in C programming. So as a sort of review, in the previous tutorial, we have learned how to use unions and how to implement unions inside our C program. And we also have implemented a simple solution or simple program that implements the capability of unions in C. So as I've said, in this video we're going to be discussing typedef, and yeah, I'm going to show you how you can use typedef inside your program or C program. So basically, guys, C is such a dominant language of its time, and even now, that even you can name those primary data type of your own, and can create your own name data type by blending data type and its qualifier. So it means that we could create our custom name for our qualifier, or custom name for our primary data type, and then we can use the keyword typedef right here. And this is a keyword implemented to tell the compiler for assigning an alternative name to the existing data types. This keyword, typedef, typically employed in association with user-defined data types, in cases if the names of data types turn out to be a little complicated or intricate for a programmer to get or to use within a program. So there are cases that a particular data type or a name of a particular data type is like complicated and it's not easy to be used inside a program. So that's where the typedef comes in. So it can be used to make the naming of our data types or variables in C a lot easier. So the typical format for implementing this typedef keyword is like this. We can use the typedef keyword just like that, and then we could specify the existing names of data types or data type. Okay, and then of course right after that is the alias, user given name. So Again, we're gonna use the typedef keyword, and then of course the existing names of data types. So there are like int, int, unsigned, um, char, and other primitive data types inside our C program. And then of course we're going to add the user given name, which is the custom name that we want to name this particular existing names data type. So this is going to make sense later on if we try to implement this inside our C program. So for now, just think of this as the syntax of defining or how to name our existing data types. So type def and then existing names of data type and then alias or the user given name. So we could add here a sample snippet. So like this, type def, okay, and then signed long, okay, and we're going to give this user given name as long, okay. So basically, guys, if you have or if you are trying to define signed long data type, so it's going to be complicated or like it's going to have a long name because you can do it like this, signed long, and then say for example variable 1, and then signed long var2, signed long var3, and so on. So as you can see, the name of this particular variable or the data type has like signed and then long keyword. So it's going to take up more space, take more, we're going to type more text inside our program instead of just using it like this. So all we have to do is define it like type def and then signed long and then s long. And then we could implement this instead of like that. We could implement that by using something s long and then g. Okay. So basically what we're doing here is that we're just getting this alias from there, and then um, it's going to include all the data types or existing names of data type here. So the s long is associated with this right here. So we can declare or create a variable with assigned long data type, something like that. And then of course we could add a variable like just like this. It will allow us to create two variables named G and D, which will be of type signed long. And this quality of signed long is getting detected from S long, okay, which already defined the meaning of is long or S long in your program, which is this particular meaning, signed long, okay. And right after that, we could make this or the concept of type def can be implemented for defining a user defined data type with a specific name and type. And this type def can also be used with structure of C language. And of course, we already have demonstrated how we can use struct inside our C program. So basically what we could do here, as I've said, we could add or use this keyword type def in our structure. So the syntax is like this. All we have to do is type in type def and then struct, and then say for example student. So this particular struct is named as student, and then it has like the members of this struct is of type char, and then say for example s name, which is the name of the student. Okay, and then we could say here int sh. Okay, so this particular struct save a data, which is the name and the age of the student. And of course, we could add an alias to our struct. So for example, stud. Okay, so just like that. And then of course, we could use the struct inside our main. So for now, let's get rid of this. So what we could do here is we could say stud and then st, something like that. And then we could see here printf and then enter student details. Okay, you could add a new line here, semicolon, and then we could copy and paste this. You can see here enter student name, and we're going to add a tab /t, and then what we could do here is use the scanf function. So %s, and then we're going to be passing the st dot s name. So all we're doing here is just assigning a value of this sts name coming from our user. Okay, and then second line, or the second information that we need, is all about the age of the student. So enter the age. Okay, so we should add \n right here to add a new line. Okay, so what we could do here is scanf and then %d. Okay, and then we could say here st dot h. Okay, and then printf just like this, \n for a new line, and then we can say here input done. Okay, and of course we could display this if we want to, to get all the information that we have entered, the name and the age of the student. Okay, but for now, let's just try this. Build and run our program. Okay, so we have here the output, enter student details. So the first name, or the first option, will be the name. So we can say here John, and then the second option is the age. So enter the age of the student. So for example, the age of the student is 18, and then yeah, we need to add, it says here that the main.exe has stopped working. We need to add the ampersand here, and then build and run our program once again. So I hope this would work right now. So John, and then the age of the student will be 18. So input done. Okay, so basically guys, we could define our struct with the use of typedef keyword, just like this. And as you can see here, we define our stud alias right here, and then we use that stud alias right here to name our variable st, and then from that, our st, we could access the members by using the dot symbol. So st dot and then the members of our struct student. Okay, and in this video guys, we're going to discuss what is file handling in C. And then I'm going to give you a basic example. We're going to create a program on how to handle files inside our C program. So basically, guys, C files, input or output functions, handle data on our secondary storage devices, such as our hard disk. And C can handle files as stream-oriented data or system-oriented data or binary files. So again, guys, we're going to focus on this. So the first one will be stream-oriented data files, and the second one will be system-oriented data files. Okay, so when we say stream-oriented data files, the data is stored in the same manner as it appears on the screen. Okay, so I hope you can see that. The input output operations like buffering, data conversions take place automatically. While system-oriented data files, the data files are more closely associated with the operating system and data stored in memory without converting into text format. So this is gonna make sense later on when we try to implement our very simple file handling inside our C program. Now, there are 5 major operations that can be performed on files. So this will be, again, I'm just gonna list it here just for you to see, because I think it would be much clearer if you can see all the details, all the things that I'm talking here. So C file operations. So the first one will be creation of a new file. The second will be opening. The third one will be reading. The fourth one will be writing data in a file. And last will be closing a file. So these are the 5 major file operations. The first one is create, again, creation. The second is opening. So we could open an existing file, and then we could read the contents, and then write data into a file. So for example, in your program, you want to save an information, so you could write data into a file. Okay. And then, of course, whenever we are opening a file, we need to close it after using it inside our program. Okay. So the steps, there will be steps for us to set up the file operations. So these are the steps for processing a file. So number 1 will be declare a file pointer. So this is important. So we need to declare a file pointer variable, and then this will be our variable that we're going to use whenever we want to work with our files. And then after that one, we need to open a file using fopen method or function. Okay, so after that, we're going to process. This will be number 3. Process the file using the suitable function right here. And number 4 will be close the file using fclose function also. So if we want to work with files inside our C program, we want or we might want to check this steps for processing our files. So we need to declare a file pointer variable, and then we're going to open the file using the fopen function right here, and then process the file using the suitable function. So for example, we want to iterate through the lines inside the file. If you want to save or maybe write information into the file, you can do that here in step 3, meaning you could process the entire content of that particular file. And then right after processing, maybe you need to close the file, or not maybe, you must close the file after closing or after processing it inside our C program. So basically, guys, there are a lot of functions that we could use when we say we're processing a file. So to handle files in C, file input or output functions available in the stdio library are the following. So I'm just gonna list it also here for you to see. So we already discussed the the two functions. The first one will be fopen, and the second one will be fclose. There are also functions such as getC, which means we read a character from a file, and then we also have putC. So this function putC writes a character into a file, and then also we have getW, which means we need to read an integer from a file, and then we also have putW, so write an integer. And we're going to use this later on, this particular functions, okay? So you need to be familiar with this. Again, if you want to read characters from a file, you need to use this getC, and then if you want to write character into a file, you need to use putC, and getW gets the integer, and putW write an integer into a file. And then we also have fprintf. So fprintf prints formatted output into a file, and we also have scanf, so reads formatted input from a file. We also have fgets right here. So fgets read string of characters from a file, and we also have the next one will be fputs, and then the last one is feof. So fputs write string of characters into a file, and then we also have feof, so it will detect end of file marker in a single file. Okay, now as a sort of example, we're going to implement a simple opening and closing of a file, and maybe writing a specific text or something into our file. So we're gonna do that right here. So at first, we need to remember the steps for processing a file. We need to declare a file pointer. So in order for us to do that, we're going to have to follow this syntax right here. I'm just going to copy and paste it here. File open. So as I've said, we're going to use this function fopen, and these are the possible parameters that you could use. Okay, so to put it simply, we could use this. We could declare a pointer variable. So fp and then semicolon, and then we're going to use that pointer variable and then use the fopen function right here, and then we could say here file name dot txt, and then another parameter, and then we're going to use here w. So w means that the file is being opened for writing, and if the file does not exist, then there will be new file created. Okay, so um, let's just return 0 for now. Okay, after that we could close our file. Okay, if we open the file, we could also close this. So what we need is to use the fclose function and then pass in the pointer variable, which is fp right here. Okay, and right after opening the file and before closing the file, this is where the processing of the file happens. Processing of the files right here. End of processing. Okay, so inside of processing, we could just simply, if you remember, we have different functions. So get c, put c, f, printf. So we're going to use this. So for now, let's just say f printf. Okay, then open and close, and then semicolon. And inside here, we could specify the pointer variable, which is fp, and then of course %s, where is it? %s, there you go, and then hello world. Okay, hello world. There you go. So after this, we could save our file and then build and run. Okay, so for now we're getting process return 0. It means that the execution of the program is successful. So we're going to try to open the file that we have created, and as you can see here, I have my project right here, from documents, code blocks, projects, and then programming knowledge. And then if we try to open this, we can see the text hello world. Okay, so there you have it on how you can write files or write lines of strings into our file by using this simple program right here. And I think that's all there is to it in this video. In the next tutorial, we're going to read text inside our files and then display it in our maybe console, or if we want to process the contents of the file inside our C program. In this video, guys, we're going to continue working and discussing file handling in C programming. So from the previous tutorial, so actually this is part 2 of the file handling video tutorial. And in the previous tutorial, we discussed the basics of file handling and also discussed the 5 major operations that can be performed on a file. So for example, the creation as the first operation, and then opening, reading, writing, and closing a file. And also we discussed the steps for processing a file. So basically, if you want to handle files inside your C program, you need to declare a file pointer variable as the first step, and then the second step will be opening a file using the fopen function, and then right after that one, process the file. So for example, you want to count the number of lines inside of that particular file, or you want to add something to that file, you can do that. So that's the processes. or processing of the file, and then of course closing the file using the fclose function. And from the previous tutorial also, we briefly discussed the different functions that we could use when we are handling files in C. So for example, the getC, the putC, getW, and putW, and the other functions. So in this video, guys, I'm just going to show you how you can read the content of a file and display it in your simple program. So we're just going to use this main function right here. So I have here the main.c file, or main.c file, and then we're just going to use this main function right here just to get the contents of our file. So as you can probably remember from the previous tutorial, we already created the file inside our file system, and let me show you that. Okay, so I have here the file and then file name.txt, and it contains the text hello world, as you can see here. So this is written from our C program, and in this video we're going to read this by using also our C program. So in order for us to, again, if you want to handle files in our C, the first step is to declare a pointer variable. So the pointer variable goes like this. So we need to call on this file class and then add the semicolon, I mean the asterisk or star symbol, as you can see here, and then of course the name of your variable. So I'm just gonna name it file name and then semicolon at the end. So this is our pointer variable. As I've said, this is the first step for handling files in C. We have to declare a pointer variable. And then the next step, since we're getting the content of a file, I just want to assign the content of a file into a single variable. So for example, I'm just going to declare here another variable char ch, or the name of the variable is ch, and then I'm just going to assume the length 100. There you go, and then semicolon. So basically, this particular variable will hold the contents of our file. Okay. Next line will be using the file name variable right here, which is our pointer variable. And then the second step in the process is, of course, open the file by using fopen function. We already used this function from the previous video. So in here, we're just going to specify the name of the file, which is file name.txt, as you can see here. So that will be file name.txt, and then we're gonna use the R symbol. Okay, that's basically reading the file name, or I mean the file coming from our file system. And then the next step is, of course, if we want to print the contents of our file, so we're just going to use the printf function right here, and then specify the format specifier %s, because we're going to display character or strings of character here coming from our file, and then comma, and then we discussed the function in the previous tutorial, fgets. Okay, so basically this function read string of characters from a file, and this particular function takes a few parameters. So for example, we're just gonna specify the parameters here. So for example, the variable ch, that's the variable that will hold the contents of our file. And then, so for example, 50, this is the count of characters that we're going to allow to be saved in our char ch variable. And then, of course, the file name. Okay. And as always, if you are working with file, since we're opening the file here, we need to use also the closing function, which is fclose right here. And then we're going to specify the file name right here. Okay. So for example, the file name, and that's about it. And we can run our program right now. Let's just save this and build and run. So it's going to output hello world. So for example, just to show you a basic example, let's just fill out our file. Hello world. This is a string from a file. So we're just going to test this. So save, and let's run again our program. Okay, so as you can see here, hello world, comma, and then this is a string coming from a file, as you can see here. So basically, we successfully read or get the contents of our file name .txt file. Okay, so now there are other operations that you may want to do in your file. So for example, you want to like count the number of lines. That's possible. Again, this particular symbol right here is like opening a file in a read mode. Okay, so R, that's basically what we use here. So as I've said, there are also other functions that we could use when trying to handle files in our C program. And of course, fgets is one of them. But there are also, so for example, we have get C. So this reads a character from a file. Okay. We also have get W. So this will be for reading an integer. And we also have fgets. That's what we used here. So fgets reads string of characters from a file. Okay. And then of course there are other functions that you could use to write. This is writing into the file. So we have put C, put W. So basically put C writes a character a file, and then put W write an integer to a file. And then we have printf for writing, and we also have fputs, okay, to write string of characters into a certain file. So I hope you understand the basics of handling files in C, and in this video we're going to be learning enumeration or enum in C. So enumeration or enum is a user-defined data type that we can use inside our C program. So it works like almost the same with struct. So as you can probably remember from our previous tutorials, we already discussed and used struct inside our C program. So as I've said, in this video we're going to be learning enumeration. So that's where our focus should be, enumeration. So enumeration is mainly used to assign names to integral constants, and these names make program easy to read and maintain. So I'm gonna be showing you a graphic right here on how we can declare, instantiate, and operate with enumeration inside our C program. So basically, guys, this is how we can um, declare the enumeration right here. So declaration, we have this keyword enum, and then the name of our enum variable. So in this case, days of week. Okay, and then we have different states. We have 7 different states here that starts from the value 0. The second will be 1, and the last one will be 6. So all of these states, these are called enumerators. So this is just the list of constants separated by commas. So this will help us to make our program easy to read and maintain, because all of these enumerators are already listed here, so we know what values to get, what values to assign to a certain variable if we want to use this inside our C program. Now, after that declaration, we do have this instantiation. So in instantiation part, we have also the name or the keyword enum right here, and then of course the enum variable that we have declared on top. So for example, this one, days of week, as you can see here, and then of course we need to assign an object of enum days of week. So basically, guys, this day is just an object of our days of week enum, as you can see. Okay, and then right after that instantiation, we can now use that enumeration or enum here in operation. So for example, you want to like assign a value to our object. So day equals and then the value of our um, enum that we want to use. So if, for example, this one, in this case, we specify that it should be Wednesday right here. Okay, so we could assign the value just like that. Now, we can use this inside our C program, as I've said, because we're dealing with enumeration or enum in C. So we can um, use our IDE to create our simple program implementing the enumeration or enum in C. So for example, we want to like implement the days of a week. So as I've said, in our declaration, we can use the enum keyword right here. By the way, guys, you can declare enum locally. You can declare enum locally or inside a function right here, or you can do it here before our main function. Globally declare our enum. Okay, so for example, we want to do this globally. So our keyword enum right here, and then the name of our, for example, in this declaration, we have the enum keyword and then the name of our variable, so days of week. So for example, in our case, we're just going to use the week variable name, and then inside here we can declare inside the curly braces. So make sure you use curly braces and then semicolon at the end of this particular line to signify that it is the end of this particular line. So inside here we can declare, for example, for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So that's how we can declare our enum variable. Again, you have to use the enum keyword and then the name of our enum, which is in our case here, week, and then open and close curly braces, and you can declare the enumerators here. And of course, you have to specify the semicolon at the end of this particular line. Now, in using this particular enum, we can do it here inside our main function. So we can, again, use the enum keyword, and then our name of our enum, which is week, as you can see here. So take note of that, that we use the enum keyword and then the name of our enum, and we can assign an object to this. So for example, day. Okay, so that's how you can specify our enum object. So enum keyword, the name of our enum, and then an object of our enum, which is day. So for example, you want to assign a value to this. So day equals, for example, Wednesday. So you can just use wed and just 3 letters if you want. But anyway, you can use also the full names of your constants. But in our case, we're just going to use the 3 letters to have like a uniform constant names. Okay, so here we can use, so for example, Wednesday. And then of course, you can print this. You can specify the %d here, and of course, the object of our enum. Okay, so let's try to run this and see how our what the output of our program. So as you can see here, we're getting 2. The value of our object is 2 because, as you can see, our enumerators, or the state of our enumerators, starts from 0. So 0, 1, and 2. So that's why we're getting the value of our object here as 2. But if we want to change this, for example, sun for Sunday, then run on build our program. So the output will be 6. So by default, guys, the value of our enumerators will be, if we did not assign a value to our enumerators, the default value of this will be 0. This one will be 1. This will be 2. As you can see, if we try to hover over our mouse here in our constant, so we're getting 2. This is obviously 3, but we're not getting the like the hover over display. 4, this is 5, and this is 6. So that's how our state is being initialized by the compiler. So it is getting like getting default values 0 until to the last state minus 1 of our enumerators. Okay, so if we try to initialize our states, so for example, we want to make this 1, we could do that. So Monday will be 1, Tuesday is 2, Wednesday is 3, Thursday is 4, Friday will be 5, Saturday will be 6, and Sunday will be 7. So remember earlier we are getting 2 coming from Wednesday because that's the default state of our constant Wednesday. But if we try to assign the value to our enum object here into Wednesday, let's try to see the output. Okay, so instead of 2, now we're getting the value 3 because we initialize already our variable and it's not assigning a default value um, to our states. Now here's an interesting facts about initialization of enum. So if there are like two enum names, we can declare same value. For example, we want to declare value for Monday, Tuesday, we can like make this value 1 and 1. So it doesn't matter for this particular example because this is allowed in C programming. So we can have two enum names with the same value. Okay. So for example, we can comment this one out and we can try to display the value of our constant. So percent %d. And instead of day, we can use Monday and Tuesday. There you go. So build and run a program, and we're getting this error right here. Okay. We're getting that output because we have specified our printf statement like this. But if we wanna have we want to display the correct value, then we're going to use this %d, and then comma in between, and then we're just gonna specify the two variable Monday and Tuesday, and click and build and run our program. And as you can see here, we're getting values 1 and 1. So that's one of the interesting fact about declaring our enum variable. We can use the same state or the same value for our constant, so it doesn't matter in C. That's because it is allowable in C. Okay. And guys, if you have clarifications, if you have questions regarding enum, you can ask questions down below.